Should I start again? You ready?
Yeah, no, it's okay. Let's start.
So they all have their own internal points. They all have their own internal programming.
Yeah.
But some of the points are only there to measure the physical world, right? So DEC systems comprise of three different types of points. There's measured values. We call them inputs to the system, right?
Okay.
Then inside of the controller, there's a processing that occurs, and that processing utilizes those inputs, and it utilizes virtual points like set points or things like that. So I might measure a space temperature, compare it to a set point. Now I have this comparison, and I have to do something. Those points are outputs. Okay? So inputs, virtual points, outputs. That's the types of points that you're dealing with on a BMS system.
Okay.
We don't ever change the inputs. That's our eyes and ears to the world, right? So what's the temperature of the room? Well, we don't want to lie to the BMS and tell the BMS it's the wrong temperature.
Yeah.
So if you're looking at a graphic and you see, oh, my space temperature is 78 degrees, they're hot. I'm going to change my space temperature to 68 degrees, now they're not hot. Yeah. All you've done is told the BMS the wrong information, and it's actually going to make your problem worse. Because it's going to say, the room's 68, start heating. Right? But you actually have a 78-degree room. You lied to your computer. We don't want to do that. So we don't change inputs. The virtual points, that we change. My space temperature is 78. My set point is 78. We're good. I don't want it 78. Change the set point to 76. Now all of a sudden it says, hey, I'm 2 degrees hotter than I want to be. I've got to cool down, right? So the first thing we have to know is what points we're allowed to touch. Don't touch inputs. Yes, change virtual points. Now the next one, outputs. That's a little bit different.
That's for DTC, the outputs?
Outputs is what the BMS is going to do in the building, right?
So measured values, outputs, and what's the third one?
Measured values are inputs. Yeah. Virtual points are set points, things like that. And then outputs is the physical changes that a controller does to the building. So let's make up a loop. This way we have a small loop. Let's say we have a room that has a heating valve in it. My space temperature is 65 degrees. My set point is 72. The output is going to go to the valve and say, open for heat, because my space is cold. The valve will open for heat. As the valve opens, the space temperature starts to get hotter, and that tells the BMS, hey, I'm at 72 now, and the BMS says, okay, stop opening that valve. Right? That's the output. Now, outputs are something you can adjust, but only if you really need to. The only points in a BMS that you want to adjust, if the programming is done properly, which we don't know about in this building, but if the program is done properly, the only points you ever want to adjust are the virtual points, the set points, occupancies, things like that, commands, right? The things that the BMS is being told to do. Inputs we don't touch. Outputs is, shit, I have an emergency. Sorry, shouldn't have cursed on your video. It's okay. Outputs are, I have an emergency. I have a leaking cooling tower. I need to force off my condenser water pump, or whatever I have to do. This way I have to stop that leaking cooling tower that's happening right now in the building, right? So you can adjust an output, and the system will allow you to adjust those outputs, but once you adjust an output, you've overridden it, which means it's like that until either the override falls off or you select the override to fall off. So I have an input of 65 degrees. I have a set point of 72, but someone overrode that valve to closed. The BMS says open, but the valve's not going to open. Because even though the program wants it to open, you've got in the middle. When it went to this way, you stopped it, you overrode it, and now you're telling it what to do. So we don't want to touch valves, we don't want to touch outputs unless we have to. We never want to touch inputs. We only want to interact with virtual points. Does that make sense?
It means like I leave everything like automatically. But in the worst case, I can do it manually.
In the worst case, you can do it manually. That's the idea. You want to leave it automatic, and in the worst case, do it manually. Now, your building has another level of complication in that we didn't program your building, right? So all we're doing is interacting with pre-existing programs. I cannot attest to the quality of the programs or how they're even written. I can't attest to the sequences of them. We don't know. All we're doing is integrating with an existing system that's in your building right now. So we've taken the controllers that are available to be brought online via BACnet over IP. We put them into your BMS. You now can see them. We created graphics for them based on the original graphics that were in the system. We recreated those graphics, and we linked up all the points so you can see those points on the screen. So now you have the ability to write to those virtual points. You have the ability to override those outputs, right? That is all under your control.
Yeah.
Whether or not it sees 65, it knows 72, and it opens the valve, that we have no control over. And if that doesn't work, that just doesn't work. There's nothing we can do about that until we get to a point where we're changing out controllers and things like that. All right, so the beginning of this process, Dinesh is going to now take you through from starting from Windows. All right, we're starting from Windows. He's going to take you through right from here how to turn on your system, how to log into your system, and how to he'll take you through changing the points, changing the graphics, doing all that stuff. When he's done giving you that tour, you'll ask some questions. Then we're going to get into the higher level stuff like creating usernames, clearing alarms, things like that, how to do trending. So he's going to get into all that with you so you can start looking at that stuff. That might be a good thing for you too. The trend on your outside air temperature, if you look at it and it makes sense, you know, it's getting hot during the day, cool at night, and it kind of has something that matches what you've seen in reality, good. But if all of a sudden you're noticing that one of the trend data says 27, then you know you still have a problem with that thing that you were dealing with before. Yeah. So trend data is really useful in diagnosing stuff, so we'll make sure that we teach you how to do how to monitor trends and see how that works. Okay, I'm gonna turn it over to you. Make it out of your way.
Do you want to stop it?
Hey guys.
Yeah.
Good morning.
Yep. So this is your Windows right now. Okay. I've just created a shortcut for the login on the desktop itself.
Yeah.
Okay. If you don't want to use it, I'm just letting you know from the Chrome. If you go to a Chrome.
Right.
Okay. Here also there is an login page which you can use. That's a shortcut. But if you don't know how to log in, just do HTTPS, okay, it's secured, and then double colon, then you go to local host. See?
And that's only from the computer here or from
So right now we're not dealing with remote at all. We're only dealing from the computer here. So remote is if you need a way to get into your building remotely.
Right.
Can we let them use TeamViewer? Can we create a
Yeah, we can.
We'll do that later.
Yeah, we can.
So we can set something up so that you can get in from your computers at home over TeamViewer that we've got set up on the computer right now.
Okay.
Yes.
So
Can you please repeat it this one again because I was not concentrated what you do.
okay, so I would start.
Yeah.
From the scratch.
Thank you.
No problem. Okay. So you go to Google Chrome.
Okay.
Okay. Once you open the Google Chrome,
Yeah.
and type HTTPS.
Okay.
Okay. Then colon.
Okay.
Double slash.
Yeah.
Local host.
Okay.
Okay. Once you type this, put an enter.
Yeah.
Then login page would have come up.
Okay.
It says the username. Right now the user is admin because we are using an admin.
Yeah.
Okay. And then you have your password.
Okay.
If you need to change the user, you can click on the change user.
Yeah.
Like this.
Change
and the
this.
new username would pop up.
So
Yeah.
the admin would be the main, and
Yeah.
then you can create users under the admin.
Under the admin. Yeah.
Okay.
So like on the user, right now I will just let you know that I can assign an admin too. Like if I create a user with your name, I can assign a role of an admin.
Yeah, Nick will be an admin. When we set this up, Nick will be an admin.
Yeah.
Okay, so right now I would put admin, enter, then my password.
So we need to know the password or not?
Well, that's his password.
Oh, okay.
When we set up your username, you'll have your own. Everyone will have their own unique password, except for Magdi. We're going to make his like password 123 exclamation mark, and then he can change it later.
Okay.
Yeah. So this is how you come up to your home page where you can see a site map.
Yeah. This is a building.
Then you can see your address down
Yeah.
there.
Yeah.
Then you have all your the temperatures and everything which is shown up here.
For
The only condition
for all
for
the
this
day.
to be shown is you need to be connected on the internet.
Okay.
Because we have taken a global kind of nearest airport
Yeah.
to pop up all these details.
Yeah.
Okay.
So you just, the only thing, if you are not connected to the internet, it would show a dash. It won't show any information.
But it would, let's say the internet's not connected, you still see the temperature sensor.
You
on
would
the roof.
you would see the temperature sensor
On the top
on the
left.
top, which says 86.7 right now.
Okay.
Okay. Apart from that, you won't see anything. On the right hand side, you have like the details, like what is the user that you have logged in. Apart from that, the current time, which is 19 June, 9:20 AM. Okay?
Yeah.
This is your all home page right now.
Okay.
Okay. So then what I would do is I would just go from left to right.
Yeah. Okay.
So on this is your home page, like, and after that you would go to your users. So
Okay.
here you can create your user.
Yeah.
Okay. Right now I just have 3 users. One is admin.
Admin.
One is the remote, like what we used to work on. That's the remote, Amy_R.
Okay.
Okay.
Yeah.
So here you can do like you can add the new user, which we can come up later.
Yeah. Here down.
Okay, new. Then on the left you have a device alarms. Okay.
Okay.
So this is a console where you would have all your alarms popped up. Like if you want to check any alarms that's coming up, you can go here and check it. Okay. We would come to alarms later once we go forward.
Yeah, because this need more explanation.
Yeah, that needs more explanation.
Yeah.
So right now, if you see, there is like 2 active alarms which shows in red. Okay?
Yeah.
And here, if you see here, it says 2.
Yeah.
So you would get to know prior that how many alarms are coming up.
Yeah.
Because we have a small number which shows 2.
Yeah.
Okay. So the active alarms, you would get it on the navigation itself.
Yeah.
Okay. Then apart from that, here we go for the trends.
Yeah.
Like you can
And
add a trend and everything.
and for the green alarm, sorry to interrupt you. For the green alarm, this solve it. This mean
green means it has gone to normal.
Gone to normal.
Yeah.
Gone to normal.
Green means it has gone to normal.
Yeah.
Your active alarm.
Okay. Thank you.
So the alarms are on which tab? On which
This one, device alarm.
device? Okay. And then how do you clear them?
We can.
He will. I think he will return it back.
I would come to alarms later, like.
Okay. But where
Yeah,
it's silence.
you can clear it. Like if from here you can right click on it, and there is an option of force clear, and also acknowledge.
Okay. And then when let's just say we change the air temperature sensor and we need to actually have it communicate with the system. Doesn't it have to be like reset or something so that it, like when we change a part, how do we get it to communicate properly?
Okay, so like if your overtime, like or a space time, which is in
like the temperature sensor, we had to change. The guy next door
That's instant. As soon as you change it, it'll just change.
on its own. You don't have to.
Correct, because that's all
reboot
that
it
is.
or
It's just
whatever?
an electrical signal. So when you're any of the temp sensors that you have in this building are either going to be 2 to 10, 4 to 20, or a thermistor. Right? That's so either it's a 2 to 10 volt signal, a 4 to 20 milliamp signal, or it's going to be a thermistor, and all of that is electrical. So as long as you don't short anything when you make a change, it'll just change as soon as the sensor's hooked back up. If you take a sensor off the wall, like let's say you pull a thermistor off the wall, while it's off the wall, you might get a number like -58 or something like that on the system. Or it might say NAN or something like that, right? And then when you put the sensor back on, it'll send, it's basically a resistive circuit with thermistors. So it'll send the voltage signal out, it gets resisted by the sensor and comes back, so you'll see it climb up and then stabilize.
And on every temperature sensor, we have like put up a high alarm and a low alarm. So whenever it goes above a certain limit, you would get a high alarm.
Is that something you guys set, or is that something that's preset?
No, we set an alarm on it. So that's something that we configured. We took the temperature sensors that you have in your building,
Right.
and we assumed their normal settings, and then we created alarms that are above those settings or below those settings to give you indication.
And if we needed to adjust that, is that something you guys do, or we do it?
Once we're done with this training, it's you. I mean,
So we can adjust the alarms.
So he can show you when he gets to the alarm phase of this, getting into the nitty gritty, how you could change max and min settings, but likely that's something you would not need to change because he didn't put them in places that are going to be nuisance. He put them in places that are actually indicative of emergency.
Okay, we'll keep our question to the end so you can explain everything.
That's probably best.
Yeah.
Okay, so the next, I just pulled up the trend. So here you can do all the trending, which we can come to later stage. I will just let you know that you can add a trend from here.
Yeah.
If you go to histories, and there is a grouping out here, okay, and from here you can just pull out a trend. Like if you just go here, show a trend.
Okay.
We can just come to that Apart from that, if you want to, change the trends or update the trends, you can just click on this.
Yeah.
Okay.
It's like a refresh.
Then I would go forward. We can go to schedules. This is the tab where you have your weekly schedules.
Schedule. Okay.
So right now we have set the schedules.
It is 6 a.m.
Yeah, 6 to 6 p.m.
6 a.m. Yeah, to 6 p.m.
And if you want to change it, you can just add the time up here.
Yeah.
Okay.
Okay.
And you
Can
can
we-
save it. If I
Let's
just
change it.
Can we make them all 5?
Make it 5. Make it 5 a.m.
5 a.m.
5.
Yeah. End at 5.
Okay. So it's
No, that's p.m.
You wanted to start at 5?
Start at 5 a.m.
Okay.
Finish, I don't know.
You finish 5 also.
6, I think 6 because there's still
6.
lab.
Okay, 6.
okay, 6. So once you change it, you would have
Save.
the tab there. You can change your settings.
Yeah.
Save. Okay.
Okay. And if you
Can we
click on
copy it or do we have to?
No. Once you done one change,
You have to do
Click.
all of them manually.
do a right click, and then you can apply Monday to Friday.
Monday to Friday.
So that way you would have everything controlled. Okay.
Yeah. Okay.
And if you want this to be, have it on Sunday or Saturday, just copy the day, go up here, paste it. Okay?
Yeah.
So that way you can do it.
Yeah.
Just remove it for now
You just clear day. Okay.
and go to this save.
Yeah.
Save
You
your
always
changes.
have to save it after you make a change.
Yeah.
Okay.
So it's not auto save.
Okay.
So what right now it says event 12 a.m. Is that for Saturday?
No, it just
Sunday is empty.
connected on this. So
Oh,
it's
okay.
unoccupied.
So are there unoccupied settings? Right now we
it's
see
in
occupied
it's in
settings.
unoccupied right now.
And what are the set points for there? Just
Uh,
everything's off?
no, the set points I can just come up when we go to the graphics. It's just the timing.
Yes.
But when it's occupied, you have those set points, right?
Yeah,
occupied,
it's
on
a
and off.
timing slot.
Unoccupied, are there different settings, like different temperature settings for unoccupied?
Yeah, we can do that, and it's in the graphics when you go to graphics.
I
can just
the
show
right
you.
column. Yeah.
Okay.
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 So this is the schedule, and you can add all this. You can change it. These are the tabs.
So we have 4. Okay.
But from that, okay, let me go to legend. I would explain you this when we go to the graphics.
Okay.
It's just a legend which shows what is there on the graphics, like what are the points, if it's an set point, if it's a monitor point, or it's an output point, just like Joshua was saying.
Okay.
Okay.
Josh, you're recording this, right?
I'm recording it.
Okay. I was curious how it was recording now. I'm seeing
Yeah.
it.
Yeah.
Okay. So I would explain you the legend once we go on the graphics.
Okay.
Okay. Then we have something called as overridden points, a tab where we can see all the overridden points. At what, like the points which are overridden and what are their values. So you can just check what are the points which are overridden.
And who overrides it? Us?
Yeah, the operators.
Okay.
Okay. Then there is a user log report.
I'm sorry. For those overridden points,
Yes, I can go.
how do we know what's what? Is that something that was overridden by?
Yeah, it was overridden earlier.
This could have been existing for a long time, or is it something that was overridden by you guys, or?
It might be with us, or it would be overridden earlier.
Okay.
Okay.
So now, do we have to remove these overridden points, or no?
You can remove them, see what they go to. If they go to where you want them to go to, then you're fine. If they don't, then put them back. But these are the outputs that we talked about that you don't want to override unless you have to.
Okay.
They're currently overridden. They could have been overridden because of programs that weren't working. No information about that. All you can do is enable them and see what state they go to.
Okay, and where it says enabled, it's enabled, but what about the 10%, 50%?
So enabled means that it is overridden to the on state.
Yeah, we did
Right?
that.
That's the
right
value.
now.
That's the value of the point.
Yeah.
So
And
binary
we
points are
mentioned-
going to show up as disable or enable. and then analog values will show up as whatever their frame of reference is. Like if it's a percentage, it'll be 0 to 100. If it's a voltage, it'll be whatever that voltage is reading. You know, so that's what. So that is the value of the overridden. That's the overridden value.
This mean in AHU01, he for supply air fan he make it like 50% in this day.
Yeah.
Okay.
50%.
Yeah. Okay.
Now that was one of the things we did today.
Yeah.
Remember, I told you when I got here, the space was hot. Your air handler is not telling the BMS that it's running. The status is off. I bet you, if I was a betting man, I would say that Siemens is not ramping that VFD because it doesn't have a status. So he ramped that VFD to 50, and it went right up to 50. Because the static pressure set point was 0.9, the static pressure was 0.4, if I remember correctly, and the VFD was running at 24 hertz, or 24%, I'm sorry. But it was saying 0 status. So he ramped it to 50%. It definitely ramped. I watched it, I was up at the unit. It ramped, and he didn't get status. So the status is not reporting back to your BMS, which may be keeping your BMS from ramping the VFD. Now, if I was the programmer, I wouldn't do that. I don't look at the status to decide if I'm ramping. I look at the command. If I want it on, then I'm ramping. I can trigger an alarm, I can do other functions, but I'm going to ramp no matter what, because it might be that holding the hertz down is preventing my status, right? They might not have programmed it that way. They might have programmed it that once I see status, allow it to ramp. But as of right now, he overrode that to 50. I bet you if he releases that, it's going to go down to that 24. You're still going to see no statuses on your air handler. So that's something that you're going to want to physically address in the building at some point. But I think you should probably address that when you decide to take over that piece of equipment.
I mean, that is an issue that we've been dealing with.
Yeah. Right now, you're manually controlling the speed of your fan is effectively what's happening.
Right, and over the winter we had to leave the fans on hand at a lower hertz.
You wouldn't have to leave it on hand. You could leave. Overriding here is hand. It's hand without being in the building, right? So you could override it here and put it on whatever speed you want, but you're still in that same situation moving forward. You're going to be in that situation until you make a change.
So how do we make it automatic with static pressure, like based on the static pressure?
All we can do is write to those points, which we're doing.
Right.
And whatever it does, it does. So right now, it doesn't seem to want to ramp. My guess is the reason it won't ramp is because it doesn't have status. So if you wanted to put a Band-Aid on it, you would figure out why it doesn't have status, get that to work. Once you get that to work, then maybe it'll ramp on its own and, Bob's your uncle. If that doesn't happen, you're still in the same situation you're in. The only way I can tell you that you 100% can fix it is if we were to take over that system. New controllers, mostly changed points. There'd be some points that we could keep. Like if there's a CT, that works for our system, just like theirs. But temperature sensors would be changed because it would have to match our controllers.
Right.
But if we took over the air handler completely, then Dinesh would write your programs. And now when you ask me, why is it ramping, why isn't it ramping, well, we'll know because we're the ones that wrote those codes.
Yeah, and we can check the program. Right now,
Yeah.
we can't.
Right now you can't look at the program. All we can do is tell you what the values of the points are.
So how can we? I mean, I know you're calling it a Band-Aid, but how can we get it to see
The status?
The status.
You have to find out: is the CT? Is it a relay in the VFD? Is it a wire that fell off? Is there's 100 things it could be. You would have to begin diagnosing that.
So is that something you guys can do, or do we have to?
That is something that we could do.
Okay.
Now it's another one of those things where if we do that, we can figure out what the problem is, and if the problem is solvable, we'll solve it, and then you're still left with what you're left with, right? So if we get that CT to report on your BMS, and it ramps, you're done. If we get the CT to report on your BMS and you're in the same situation, it's time to look for something different. And the reason why I call it a Band-Aid is because instead of healing the problem, you'd be trying to heal a symptom, a piece of the problem, right?
Right.
So the best method, which may be impractical, but the best method would be to take over control of that unit. New controllers, some new points, new checkout, new programming, and now you have a fully, not integrated, you have a fully programmed Honeywell AME air handling unit. And now your air handling unit is 100% in your control, not just integrated. But that's something you make the decision on later. So you can keep going with your training, but that's how you solve that problem.
Okay, but we at the end of this, can we discuss that issue?
I'm working on some stuff right now.
Yeah.
This way I can kind of give you a ballpark of what you're looking at. I mean, it's still needs to be refined, but I'm going to try to give you something.
Right. Okay.
So then there is a user log report, okay, which we have created.
Yeah, it's loading.
It's slow because a lot of things.
Yeah, so many.
So then we have here is audit history. Audit history is anything you do in your BMS, it gets logged.
Okay.
Because that's why it's called audit history.
Yeah.
Because you change the set point, it would get logged. You get in, it would get logged.
Okay. Okay.
Then, apart from that, we have a log history. Log history is like what is going on the network. Like what controllers they are pinging, what is the transaction type. If you see, that's all like backnet.
Yeah.
So anything which is going over the backnet, you would get that in the log history.
Okay.
Okay.
Yeah.
And then we have a security history.
So anything not on backnet you don't see?
Like backnet or any other network. Anything related to network is there on the log history.
Okay.
Okay. Then we have is security. Security is the user logged in at what time and everything. All related to your security itself. Like if someone has changed anything, it shows on the security. So it's just related to security of your BMS, your controller, the supervisor.
Okay.
Okay?
Yeah.
Then there is a logout button.
Log out.
If you click on it, it would just log out.
Yeah.
Okay?
Okay.
Any confusion?
No,
So
nothing.
that's the left.
Left bar.
Okay.
Nothing except the alarms.
Yeah,
It's
I will
all-
come to that.
Yeah.
Sure.
Yeah.
Okay. So then this completes your left side.
Okay.
And I go to your right side, which has on the top says the flow. So that's your flow plan with all the numbers.
It's level number 6. Yeah, floor number 6. Okay.
So Joshua, we don't have the VAVs right now, right?
We don't have the VAVs. No.
But you have the temperature sensors?
No, temperature sensors come from the VAVs. That's part of that change order if we wanted it to do the gateway kind of style from the Siemens network, or if we wanted to take over the floor, that's part of that.
So how do, I mean, on the Siemens system next door, we're able to see the temperature on the third floor. There's
Correct.
nowhere we could see the temperature on the third
We
floor.
can't get those VAVs onto the system unless we do what we talked about. That's that first change order that was going to create the gateway points in their base controllers.
And then, are you able to set from one of the, let's say we say room, I don't know. Oh wait, can you go to the third floor?
Third floor? Okay.
Let's say we say room 3103. Can we somehow say we want the floor on that room sensor to be 73? So we base it off of that sensor for the whole entire floor, or no? Can you get the
VAVs are
reading and say,
VAVs are individual, right? So you could, if you wanted the whole floor to be the same temperature.
not the VAV, the temperature sensor. Can we grab a temperature sensor reading from one spot on the floor, or multiple spots if you could do
and
it?
tell every VAV that's the floor's temperature.
And that's where we want to be the adjustment.
He want to control one room.
I want to be able to keep the manager, which is 3103, at 73.
This
Yeah. So no, it wouldn't work like that.
So she doesn't complain.
So, yeah. Duct tape. Have you tried duct tape? No.
because some people feeling
By the way,
cold, some
while
people
we're
feeling
talking, they're
hot.
telling me the IDF closet is 86 degrees,
Yeah.
and I'm like, I give up.
So the way it would work, because there's a few different things, right? So let's say we did the gateway concept that we discussed with that first change order, right? If we do the gateway concept, then you will have the temperature reading for every VAV, you will have the temperature set point for every VAV, and you will have the airflow current volume for every VAV.
Can I pause? There are temperature sensors like that
Yep.
on almost, I don't know, every 3 or 4
Associated
rooms.
with there'll be 36 of them on that floor.
Yeah, so that's connected to the VAV
Correct.
for that, let's say, 3 or 4 room.
Yeah, there's 36
Backed up.
on that floor, so whatever those 36 zones are.
So
One
36
temperature
sensors
sensor. There's
per
36 sensors.
VAV
Yeah, one per VAV.
grouping or whatever.
Correct.
3, 4 rooms or
So
whatever.
like this sensor here likely controls just a VAV for this one room.
Right.
Likely, right? I mean, I don't know. I'm just telling you. More than likely, this room is isolated and it's not grouped with anything else.
Right.
So that sensor goes to a VAV. That VAV controls a damper that allows a certain volume of air in this room. The program in the VAV says, read the temperature. What do I want it to be? Adjust the damper based on that. Cooling only. So if the space says I'm cold, I want to be hot, it just goes to minimum, doesn't do anything with heat. Just goes to minimum airflow. If the space says I'm hot, want to be cool, then it'll open up as far as its maximum air volume. Right? So there's a set point inside the VAV that's not adjustable. That'll be the maximum volume that the VAV is allowed to do. Then there's a set point in the VAV that says what's the minimum volume I'm allowed to do. Now all the VAV is allowed to do is move between those two volumes linearly, right? So it's a proportional reset between those two volumes. I don't know how they're programmed, but that's likely how they're programmed. All right? So it measures the temperature, adjusts the damper to give that volume. That volume is calculated based on the difference from the set point and the temperature. Right? So let's say the span is 2 degrees. At 2 degrees hot, you'll be at maximum CFM. At 0 degrees hot, meaning you're at set point, you'd be at minimum CFM. Between 0 and 2 degrees, you'll be at some proportion of the max and min, right? Somewhere between max and min, right? So that's how that works on your floor. You have 36 of those on that floor. You can't see them the way this system is. If we wanted to see those data points, what we would do is take those data points from the VAVs, we would mirror them in the floor level controller that we can see,
on the floor,
and then we could then tell your BMS that information. Now, if you were to make a set point change, it would go up to the mirror point and back down, right? That's how that would work. So you can keep that going, and that would even be after we separate, it would still function, right? Now, that's how we could do it. If you were to actually take over control of the floor, Jason VAVs out on the floor, then the full programming of the VAV belongs to you, which means we could reverse the action of the VAV in wintertime. We could turn your air handler, if we take over control of your air handler, into a heating unit, and we can give you heat from your VAVs. That's an option. Not something you may want to do, it's just an option.
Right.
So moving forward, there's a bunch of ways to skin the cat, so to speak, right? But you can't do what you just said, make her room the only room that matters on the floor. That, number one, you wouldn't want that. In the end, that would actually cause you problems. What you want is every room to be at the right temperature. The thing you'll always have to contend with is your perimeter heating is not on the BMS at all. It is a automatic control valve, Danfoss valve in the space.
Right,
So
that's the heating part. But let's say the cooling part right now.
the cooling part would be
she's-
open
like
the
yesterday
damper to
she
max
said
in
it's
the space.
79 degrees in my office.
Then the question would be, what's her set point? And if her set point is lower than 79, then it doesn't matter what you do, because that VAV is not doing what it's supposed to do. And we wouldn't be able to change that. Right? But if the set point is 79 and the space is 79, well, it's not going to open. And then if you were to change that set point to 76, then it would open. Right? So if we did the change order method, you would have temperatures, set points, and air volume. That's all we would give you on the floor. You would know what your air volume is, we would know what your temperature set point is, we would know what your temperature is. If you do the takeover, you have
the
full
other
control.
thing that was on their screen, you have the screenshots from the screen grabs that you guys provided. So there's another thing that's on there that says average floor temperature read, I guess.
Yeah, everyone does that, right? You
Can
read
you
all of them.
adjust that? I think what he was able to do was click onto the average floor temperature, whatever it was, and adjust it.
So, not typically. Each zone typically has its own set point. You could make it so that you have a floor override, which says everybody's going to go off of one set point. And that means all the VAVs are listening to one set point. Nobody gets individual control. That's always the better way to do it from your point of view, because 77 and 75 don't feel very different unless you're walking between two rooms where one's 77 and one's 75, and now you have jealousy, right?
Well, there's a 4-degree, 5-degree difference from one side of the building to the other.
Yeah, I mean, there's multitude of reasons that could occur,
Right.
but VAVs tends to help with that. That's
Right.
the idea behind it. You're not going to have full control unless you take over the floor. You know, I mean, that's really what it's going to boil down to. There's no real half measure that's going to give you full control. There's a half measure that's going to give you more control. That's the change order that you have in place right now, which is a cheap option of giving you more control. As far as giving you full control, you know, that's what I'm working on right now. You want to know a price for the third floor, so I'm going to work on giving you a price for the third floor. Now, keep in mind, even giving you a price for the third floor, that's giving you control of the VAVs, but it's not going to give you full control of the air handler or the chilled water system or the hot water system. Right? The totality of the building is going to be full control of hot water, full control of chilled water, full control of AHU1, then your VAVs. After that, everything else is a la carte, however you want to do it, because it's really small stuff after that. Like this floor is on its own air handler. I think your cafeteria might be on its own air handler. So you have a couple things that you would do maybe later down the line. But the bulk of your systems is hot water system, chilled water system, AHU1, and then VAVs on the floor. And I'm going to work up a price for VAVs on the third floor for you now. Okay. And then I'll get that to you hopefully, I would say maybe by middle of next week. And then you can decide what you want to do with that. But I also don't think that the VAVs on the third floor should be your first move, personally. I think the first move you should do is your air handler. Because you could force your chilled water system to make chilled water. You could do that manually at the chillers. You could put pumps in hand, you'll be fine. You could force your hot water system to make hot water, right? Your air handler, you can't control the functions of your air handler. You can't control the dampers. It's all done by your BMS. So the first thing I would do if I was in your seat is take over that air handler. Then the next thing I would do is take over your third floor VAVs. Then the next thing I would do is take over your boiler and your chill water system. That would be the 3 jobs I would do, and that would be the 3 orders that would be the order I would do them in. Air handler, third floor, then your primary systems. After that's done, you go floor by floor as you bring in tenants, and then the appropriate systems like makeup air units, things like that, you can do that slowly over time.
Okay. So prior to Amy getting involved, we thought everything was controllable based on the supervisor next door.
Everything was controllable based on the supervisor next door. From next door, you could have used Siemens systems. Siemens has access to Siemens programs. So you would have had, what I'm trying to give you here, you would have had from their system over there.
Right.
You didn't want their system over there. You wanted to put in your own BMS. You now have a BMS that's integrated to their controls. Now, if you want to expand your BMS so that you have control of floor by floor, you can do that. Otherwise, you can have this. I mean, this is the...
But for the air handler situation, there's control there, and they're able to make adjustments.
Yes.
I mean, I'm just thinking out loud right now.
Yeah.
Should we get a Siemens supervisor since it's an integrated system and have both, just in case you need to make changes?
No, I wouldn't do that.
Because
For that matter,
now you have to go to their supervisor to make the change order.
So in order to do the half measures that we talked about, right, I would have to do something from their supervisor. Yes, because I have to create those mirror points. Right? We happen to have a guy that can program in Siemens stuff, so we would go over there. He would do some of that programming in their stuff, get that to work, and then over here you'd be able to see it, right? And you'd be able to operate those set points. That would be what we would do for the half measure. It's a half measure, so in the end, it's still a half measure, right? I mean, like that's the situation here, and it's still a half measure. If you want to do the full control, I don't know if you're not expressing to me, but if you want to have your BMS as your BMS, not interacting with them in full control here, you are now at the baby stage of it, right? You now have a BMS in this building that is talking to the stuff that's already here. Now that you have that, it's time to start taking over one piece at a time so that you end up with your own BMS that's not even associated with it. At some point, you will have 0 Siemens stuff in this building. That's what you're doing. You're doing the first part of taking over this building. Right? So if you want to fully take over this building, you have to do the next part. And if I was advising you, which I guess in some ways I am, I would advise you to make the very first goal fully taking over that air handler. We draw a picture of the air handler, all the sensors that are on it, we decide if we want additional sensors, we figure out what sensors that are there would work with our system, we replace the controls, we hook up those wires, we run any additional wires that we need, program it, graphics, testing, Bob's your uncle. Right? That's how I would do that, and that would give you Air Handler 1. Now, after you have Air Handler 1, you see the full control that you have over Air Handler 1, you like it, move on to the third floor. You put in a Jace on the third floor.
Well, there's 2 air handlers side by side. You would do both at the same time.
It's not 2 air handlers, that's two supply fans on one air handler.
Yeah,
the air handling unit is the return fan, the 2 supply fans, the coils and dampers. Okay. That's the entirety of the air handling unit. Right? So if we were to take over that system, that AHU1 system, you would then have full control over AHU1. After you have full control over it, exactly, say there's 2 supply fans, 1 return fan, that whole system right now is still controlled by Siemens and we're just interacting with it. I would take over every point on that. I would own the valves, I would own the dampers, I would own the sensors, I would own the static pressure, I would own it all. Once I have that, I can write my own sequence, Dinesh will program it, and then you will have exactly what we decide together you want.
So, but with the integrated system, we could make adjustments here to the fan.
You can make adjustments, well, you can manually adjust the fan speed, you can adjust the static pressure set point. Yeah, right here. Dinesh, change the fan speed.
No, but manually, can we relinquish it so it can be automatic?
Yes, make it automatic. Now, what it does in automatic, we can't control. Right? So now, Dinesh,
Because you
change
don't know
the
what
static
the
pressure set
what they're
point.
programmed.
Make the static pressure set point 2 inches. Don't override. See if you can set it. See if we're allowed to set that without overriding.
To set it?
Yeah,
Do 1.2. I don't know.
Yeah, no, put it up to 2 inches.
Yeah, he needed 2 inch.
Okay.
Was
Now we
it
just made that static pressure set point 2 inches. Theoretically, those supply fans should ramp up right now. Because what pressure do we have in that duct? I can't see it from here.
0.9?
112.
Oh,
0.12. You have no pressure in that duct right now. So theoretically, those supply fans should be ramping to the roof right now. And they're not moving. They're not moving. So I can't tell you why they're not moving, because that part we can't control. Now, put the static pressure set point back to 0.9, because that's where they
and
want.
that's the spot used to change the static pressure set point for.
Now, well, I'm going to explain a couple things
AHU1.
after I have him do some stuff. Now, put the fans up to. Put them
Oh,
up
it
to
did move.
0.9.
They were down to 0.23. They were 0.24 before.
No, it was 0.19.
0.12.
Go back to 2 inches and let's see what happens.
Just on the set, it's taking some time to.
I mean, it's been sitting here at 0.12 all day, so that thing should have ramped up in the background, even overridden.
So it's
not ramping.
0.17. It moved.
It may be moving. It's not doing what any of us would expect it to do. So they might be looking at other things that are prohibiting or allowing their controller to modulate that speed. So it's not doing what you want, right? We can control the output and we can tell it what static pressure we want, but it has to do its own control because we're not in charge of the programming that modulates that fan speed. If we were to take over control of this air handler, then we would be in charge of the programming that modulates that fan speed.
Okay. Do we need Siemens to make any adjustments to the programming
I
so that we could have a better integrated system? Like,
It's
can we
between-
work with Siemens or not?
We can't. No, I mean, there's nothing that we can do with that. So we're part of the puzzle of removing Siemens. So if you want to be with Siemens, that's
Well, our original goal was to get our own supervisor and have control here. That was our main goal, and,
Right.
and be able to control the system. But right now, it's like we can't even control the third floor temperature.
well, you can control only what you can control. The third floor temperature heat is fully controllable in the space.
Well, the heat, but
Right? The VAVs are controllable right now only through the Siemens system because we can't bring them online unless we either do that half measure or take over the VAVs. So it's a decision. It's not a you
right,
can't
but,
do something.
But
You
today,
just haven't done
I'm
something.
not able to basically monitor and control the third floor.
Not unless you either do the half measure or the full measure. Right? So you just know your information now.
So we have to basically walk up to the third floor, look at the temperature on the wall, and then make adjustments.
You have to decide whether you want to do a half measure or a full measure. That's the only thing that's going on here. There's only one thing preventing you from controlling the third floor, a decision.
Hold on. Whatever you do today and show us to do, we still need to go next door and control the third floor.
Yes. If you decide not to do the mirror points, or you decide not to take over the third floor, this is your forever. If you decide to do the mirror points,
In other words, it's not fully integrated yet until
it
we
is
do.
fully integrated.
Yeah,
It's,
but
there's
we
no.
can't make any changes to for the third floor.
You're not following what I'm saying. I'm trying to get you there. At the state you are at, you do not have what you want, but there is a path to what
I
you
just
want.
want to explain what I want. I want the third floor at 73. from this screen, can I change?
No.
Right.
Right. That's not
I have to
that's
go
not a
next
me
door.
problem. That is a decision problem. Would you like to control the third floor?
Okay, but when we first started, when we first got, I'm not going to throw this on you, but when we first spoke to Christian, we understood that we would be able to control the third floor and, you know.
So what was explained to you, and whether or not it was explained as clear, I mean, I'm trying to explain it now, and it's not. We're not getting to a place where we
No,
understand each other.
I'm understanding
So-
that I can't control the third floor.
Okay.
That's what I'm
And that's good that you understand that you can't control the third floor. The question right now
And the
is
first floor.
the third floor. The question right now is not can you control the third floor. It's did you do what you need to do in order to control the third floor. All you bought now is integrating with the controllers that are here. Anything that could be integrated. Now the VAVs are isolated through their floor level controllers. They cannot be integrated to this system as they sit. In order to integrate the VAVs to your BMS as they sit, you have to do another thing. You either have to do the half measure, which will give you more control,
Right.
but not full control, or you do the full measure, which will give you full control. Those are the two options. Right now, you can see what you can see, you can write to what you can write to, and you have to decide if you're fine with this, or if you want to do the next step. But the next step, you have to decide.
I hear you, but once you leave today, I'm basically stuck.
Once I leave today, you can use the BMS that is integrated with the controllers that are integratable with your BMS. You are not stuck. You are at the next holding point. Instead of you doing a whole job, you did the beginning of a job, right? You did not do a whole job here, right? You did the start of a job. You integrated the controllers that are in this building and you put in a new BMS. You have a new BMS. You have a supervisor. It is integrated backlit over IP to all of the controllers in the building, and everything that is writable is on your system. We recreated all those graphics, so you have a fully integrated to this building BMS, but you thought the word fully integrated meant more. It doesn't. If you want more control, we have to now go deeper into this, and either there's a half measure we came up with that'll give you some more control, or there's a full measure which will take this new BMS that you created, that is now a functional new BMS, and we'll take that floor and put it on it. So if you take that floor and put it on your BMS, you'll have full control of your floor. But you don't have that right now. Right now, you just have a new BMS in a building integrated to the existing controls. If you'd like more, we can do more. But you can't do more without doing more. There's another step to do here. You did the beginning process. You have a computer.
I'm understanding what you're saying, but from our shoes, we have no control. Like when the third floor tells us we're hot, I can't make any adjustments, is what I'm understanding, unless I do it manually.
You can use this to do it manually. Or Siemens programs will have to do whatever they do.
So that means that every single day we're going to have to make adjustments.
Unless you take the next step. Right now, you don't have a different building than you had when you first bought this place. It's the same building
But
that
it
it always
was
was.
on automatic next door.
And you were still having temperature issues. So even though it was on automatic, you have temperature issues. You're still on automatic, but you have temperature issues, right? No problem.
No, there's
with
a lot of stuff on hand right now.
You always had that situation, right? The situation always presented itself where you had people who were complaining on the third floor, whether it was that system or this system. All you have now is the ability to see it from this building. You started a project. You now have a BMS in this building that is connected to all your floors and integrated with your existing controls. Existing controls.
Right.
Your existing problems still exist.
Okay.
Now, if you want to go deeper and get rid of problems, you have to now do the next step, right? You haven't taken over the air conditioning and heating system in this building. All you've done is looked at the air conditioning and heating system in this building and interacted with it. You are not taking it over yet. If you want to take it over where you can solve your own problems, you have to do the next step, which is take over, not
And you're
interact.
talking about replacing, putting in a Jace controller.
I'm talking about going, so like I said, step one, in my opinion, would be to start at the air handler, put in a Jace controller, take over the air handler completely. After that is done, step two would be to go to the third floor, put in a Jace and all new VAVs, and do the work on that floor, fully program that floor. Now you have a fully programmed third floor, a fully programmed air handler, and you have integrated hot water, chilled water. Then your next step would be to take over hot water, chilled water. At that point, you have your own BMS with your own hot water, your own chilled water, your own AHU1, and your own third floor. Now you're at a really good place to slow your roll and then take over system by system as you bring in new tenants. But you have not yet taken over your air conditioning and heating system. All you're doing is looking at it through your new integrated BMS. But that's it. It's just looking at it. We've integrated this BMS with existing controls containing existing problems, like a supply fan that doesn't report status when we know it's on.
Because the start set point is at 2 inches of water column, it should at least be at 90%.
And where are we at right now?
36%.
So it's
36%
ramping
on what?
somehow, so it is trying to
For the
listen,
speed.
but
Fan
we're
speed.
so far from
Where is
static.
that? Where is that?
Down there underneath where it says start,
36%.
those two speeds, right?
It-
now look.
it's supposed to
Dinesh,
be-
Point to where it says stopped at status.
So that's supply fan 1.
Yep. And supply fan 1, supply fan 2. That's the information
So
about
that
those
if
fans.
it was stopped, it would say stopped.
Now look at the status. See how the status says stopped?
Stopped. So
We
that-
know it's running,
the fan is running, but we are not getting the
but we're not getting the data from
feedback.
it. That data is real data in the Siemens controller.
Yeah.
So there's a problem with that, right? That problem's still here. And that problem stays here until you do something
Can you
about these
have
problems.
someone look at that and tell us how to fix it, or give us
I
like is it a wiring issue, or is
would
it,
just get you a service guy for a day. I mean, we could do something like that. You know, I mean, I could give you a
because
price for a
this
service
is
guy for a
like
day.
stuff that we need to have control over.
You still won't have control over it. I can give you a service guy for a day. He'll diagnose it. If he can repair it, he'll repair it, right? That's going to give you that piece of the puzzle. Your status shows up on the screen. Does not change your level of control. This is what I'm trying to tell you. If you and I'm going to use a phrase, and I don't mean it to sound anyway problematic, but if you nickel and dime your integration into this building, you will have these problems forever. Your first investment in this system should be large. Your first investment should be large. You have a BMS here. Your next investment really should be to take over your air handler, then your third floor, then your systems. Now that's how I would break it apart if you wanted to do it staggered. If you wanted to do all of those at the same time, that's the best move, but that would be possibly cost prohibitive. But the first thing I would do if I was you is I would take over this air handling system. We will have full control over the chilled water valve, the hot water. It will be automatic control. You will never touch it. You will set in set points and it will just work all the time. Because we will be in charge of that and we will make sure it works all the time. You will have a warranty on it. We will warranty our programming for a year, even 2 years if we negotiate that into the deal, right? So you'll have a warranty, you'll have new programming, we'll have full control of the controllers, there'll be a warranty on the controllers that are up there. It will be 100% in your system, not integrated to existing controls with existing problems. Or we can go up there and just try to find out if the status fixes something. But that might not fix it because you have to deal with the fact that there's programs behind the scenes that are untested and obviously problematic. So the only way to really give you what you want is you have to decide, I want this. And once you decide I want this, then you have to buy it. And when you buy it, we'll give it to you. It's just the only way we can do it.
But what you're, I mean, it's there's an existing Siemens system that should be doing it. So should I be calling Siemens and say, hey, your system is not?
That is up to you. I mean,
Should I have Siemens fix
I think
that?
what you should do is have me do a job to give you control. That's what I think. Now, if you want to deal with Siemens because you're trying to find a way to make this cheaper or think that you're getting, that's between you, your contract with 500.
It needs to work. So right now, if we're
Right,
saying
and
it's
I'm
not
telling you
reporting
that
status,
from where I'm sitting at this
either
table,
you guys fix
from
it
where-
or they fix it.
right, and what I'm telling you is I can fix it.
Okay.
I cannot fix it the way you want me to. I can fix it by taking over that system and programming it properly. And if I do that, you will be satisfied with what I give you. Now, if you want to deal with 500, you want to deal with Siemens, that's all your own prerogative, and you can choose the things that you want to choose. But I'm telling you, if you want what you want, and I understand what you want, I can give that to you. But the only way I can do that is that you have to make the decision that you want to move forward that way. If you're going to question this and say, well, maybe Siemens owes it to me, well, then go talk to Siemens. Maybe they owe it to you. I don't think they do because they don't even support 500. That 500 building is calling me to see if I could take over that building.
No,
Now
I
that
understand,
building,
because we told Dan.
well, no, the lady I spoke to, she's been speaking to me, and I will take over that building, but I will not take over that building the way this building was taken over. This is not how I do jobs, where you just do a piece of the job.
Right.
If you want,
But what you're explaining to us was not explained to us initially.
I wasn't here,
And-
so
right.
I can't.
But when Christian and Ricky
but what
came,
Christian-
I'm just gonna let you know. Mosad was with me, Maggie was with me, it was Ricky, and it was Christian. So what we understood was all backnet, anything that's backnet would be able to be pulled into the system and controlled. That's what we understood.
Anything back.
But we were not
misunderstood.
aware about this other programming that
Yeah, I think that
we thought the programming would come from Honeywell or this.
the programming can't come from Honeywell, right? And not for nothing. And I know you couldn't buy the programming for the price you paid.
I
that'd
don't
be
know
impossible.
what it cost.
No, I'm just saying.
I'm just saying what we thought based on this supervisor, we thought we were able to make adjustments and actually put
You
things
are
on,
able to make adjustments. We just made adjustments.
right, but to make it on automatic and that everything would be.
We can
readable.
put it all on automatic, and we can make adjustments.
Okay.
That you have. You have that
So
now.
we're able to put the third floor on 73 and keep it on automatic?
I'm able to put anything that comes in on BACnet in automatic and make adjustments. Whether
Okay.
or not it works has nothing to do with me.
Right, so can
So
we?
you just watched him adjust the static pressure set point to 2 inches. We're staring at those fans. They're slowly ramping. Maybe it's going to get to the 2 inches. I don't know what Siemens programs are going to do. but I just showed you that we're
speed's at
integrating.
41.
So it's climbing. So perhaps one day it'll get there, right? Now, it would have worked already had we programmed it, right? So maybe this is doing what it's supposed to do.
But
We don't
doing
know.
so, yeah.
All I can tell you is we've integrated. I just showed you that it's in automatic, and we made an adjustment. That's what we're talking about.
Right.
I can adjust things on this screen, integrated into their controllers, and we can read the things that they're doing. Now, whether or not it does what you want it to do, or it functions properly, that's not what we're doing. We're not writing programs in these controllers. We're bringing these controllers onto your system. Any controller that is available to be brought online to the system has been brought online to the system, and we are integrated with it. The function of those controllers, the function of the data points, all that stuff, has nothing to do with us. If you want the function of the controllers to have something to do with us, if you want a reliable BMS man, right, which
Right.
currently right now neither you nor 500 seem to have, right? If you want a reliable BMS man, the 2 men standing in this room talking to you will be those men. We will be your reliable BMS men. But right now, we've given you that which we were supposed to. We've integrated into your system that exists
Right.
with its existing problems. I would like to give you what you want. And the only way we can do that is if we move forward. Now, I've given you some half measures to get you better. You haven't said yes to that. This is going back 6 months now, right?
No, we do want to do. How do we get you in front of that screen to do it?
If you just tell me, no problem, let's do it. And then
Okay,
Ricky comes down here and do it.
Let's do it. So how do you physically?
You just sign the paper and send it back to me. Right now, you haven't signed any papers.
They're not cooperating with us.
Well, I mean, you have to get them to cooperate.
Right.
That you have to let
And
them do.
we're
I mean,
supposed
Ricky
to
was
be-
able to go over there when we were over here the first time, and they didn't have a problem with it.
Right, but if we're going to tell them you're changing set points, then Siemens has a problem with it. So you're going to have to go there and say you're.
Well, then the answer is
Monitoring.
real simple. The answer is real simple. Don't do the half measure. Let's take over the air handler.
And what would that cost? But wait, you're saying air handler, but we got to be able to see the third floor temperature.
So if you want to do the third floor first, you can. But seeing the set points on the third floor and controlling the VAVs on the third floor won't help you if the air handler doesn't give us what we want, right? You need an air handler that gives you the pressure you want and the temperature you want, period. We can work with the air handler in terms of efficiency with economizers, things like that. But if that air handler is not giving you set point, what's the temperature set point and the temperature right now?
The temperature set point is 55 and we are currently at 72.
And the chill water valve says it's 100% open, though,
Yeah.
right? Okay, so it's trying to get there, it's just you don't have the chilled water. So it doesn't matter what you do on the third floor, you've got 72-degree air leaving your air handler right now. Your chilled water system isn't working properly, your air handler's not working properly. If you don't have the source of your temperature control, how can you have the termination of the
So I'm
temperature
sorry.
control?
This should say what the chilled water temperature is, not the
No, the chilled water screen tells you the temperature of the chilled water.
Right. So where's the chilled water temperature?
That's the chiller temperature.
So is this chiller 3?
70.4?
Or is this just chiller 1 and 2?
No, 1 and 2.
No,
Oh, chiller 3.
chiller 1 and 2 is
They're
not
decommissioned
working.
right now.
Chiller 3. Chiller 2. 1 and 2.
So that's your chilled water. Supply temperature set.
So you're saying
What's the temperature leaving the chiller going into that heat exchanger?
That's 59.7.
Okay, so right now you've got 60-degree chilled water. You can't do anything, right? You can't do anything with 60-degree chilled water. That's not chilled water. Chilled water isn't chilled until you're down in the mid-40s. 45 would be the hottest that you could really let chilled water go to control a building like this. So you don't have the ability to control your temperature. So even if I went to the 3rd floor and made every temperature 68 right now, wouldn't do anything.
right. Well, that's because it's trying to supply. I guess because of the temperature outside.
Right, you
it's
don't have
not-
enough chiller right now.
Right.
So this is what I'm trying to tell you. If I was doing this job, I would first take over your air handler because that's the only thing you can't do anything manual on. Right?
Okay.
You cannot touch your air handler manually. Right? I would take over the air handler. Now you have full control of your air handler. You can force your chillers, fix your cooling tower. You can run these things in hand. Anyone can turn on a chiller and a cooling tower in hand. But it may cost you a little bit of money and energy. Put your cooling tower on 100%. Put your chiller on, set it to 44 degrees. Turn your pump on in manual and run it at 50 hertz, whatever it is. You're going to get chilled water out to your building. Your air handler's under control. Now I've got cold air going to your spaces. The VAVs are doing whatever the VAVs are doing because you don't have control of that yet, right?
Right.
Once you're at that point, the air handler's done. Your next project is your VAVs. Now you've got your air handler and your VAVs. Then your next project is your plant. You do boiler and chiller same time. You do your plant systems, right? Now you have basically complete control of your building. Not complete, but I would say at that point you're 90%.
Okay.
Now moving forward from there, you do the floors as you bring in tenants, or when you have a little bit of money in the budget, you do the superfluous systems like the cafeteria or the first floor, and you slowly take over your whole building. But step one has got to be you make a move. And yes, it's gonna have a price attached to it, right? Taking over that air handler is not going to be cheap. It'll be cheaper than the 3rd floor. It'll be cheaper than the 3rd floor. The 3rd floor, I'm buying 36 VAVs. I'm terminating 36 VAVs. I'm replacing 36 space sensors. There's a lot more work on the 3rd floor.
So you would replace those sensors?
Every one of them.
You can, but
Can't use them
why not?
because I'm going to put Honeywell VAVs in, and I'm going to need the Honeywell sensors. So it'll be all new sensors on your floor, all new VAV controllers in your VAVs, a new Jace. Everything comes online. Dinesh programs, you create graphics. Now we have full control of the VAVs. Air handler, VAVs, plant. After you're done with that, you could take over the perimeter valves on your 3rd floor only, replace those valves, and run DDC. Now you actually have full control of your heat from your BMS. This is you bought this building. I don't know how long you're planning on keeping this building, but if you're planning on keeping it for a while, this is a project that should take, if you're doing it in phases, 5-6 years. You do a project every year, right? You put, in the beginning, it'll be bigger projects, $100,000 a project, somewhere in that area. And then by the time 5-6 years are done, you're basically at a place where you have everything that you wanted.
Okay. I guess for today, we just need to be able to keep the tenant happy.
That's not what we're doing today. Today you're
No, I mean whatever we're able to control, whether it be
today you're
manually
learning
or whatever.
how to control what you can control. But that's where you're at. I mean, you can control what you can control. He's showing you how to change set points. He's going to show you how to create users. We're teaching you how to use the BMS. Now, the BMS is integrated with the controls that are in the building, and we can show you how to make those adjustments like we just did. Show them how to do the set point change on the static pressure again. All right, so go back to the air handler. Now show them. Tell them what you're doing. Right clicking, left clicking.
I would be doing a right click here.
Set.
Go to
You
set.
have override, auto, and set.
Now, whenever it's a set point, those are the green ones. You want to use set because that's controlling the virtual point. We don't want to override. So you hit set. Now it's going
Is
to
that
open
the
the
same
window.
as relinquishing or
Auto is relinquishing. Override is forcing. So in a situation where you have a set point that is a virtual point, but it's controlled by a control loop. Let me give you a for instance. Let's say a hot water system supply temperature set point. Usually hot water supply temperature set points are not direct controlled by the operator. We would say, if outside air temperature is 0 degrees, make the set point 170. If outside air temperature is 60 degrees, make the set point 100. There's something to that effect. And then it'll be a proportional reset between those two values. So that set point, if you want it to change, you would have to override because there's a program writing to it. Then there's other set points that are not being written to. This one is not being written to. This is a user adjustable point. So he opens the GUI window, he changes the value, make it 1.9. Now he hits OK.
Well, no, it was 0.9.
No, I don't want to make it low. I want that fan to ramp up. So I don't want to make it low right now. I want that thing to get up there. So he just changed it from 2 to 1.9. That's us adjusting the set point in that controller. And it appears to be listening. It's just doing a crummy job of it. You know, it's just not doing a good job of it. So it does seem to be ramping that fan now. It's just taking forever to get there. And you're still looking at, what is that, 0.3 inches?
No, 0.35.
0.35.
0.41.
Okay, so right now you have not even a half an inch of pressure in the duct, and we're still at not even 50% on the van speed.
No,
It's
45%.
45%. We're not even at 50%. It's crazy. It's crazy.
So, I mean,
That fan speed should already be up to 90%. But it's not.
but 90, like when it does go to 50%, it's going at a very high rate. The RPM is like,
I saw it today. 50% is going at 35 hertz. That's what it's supposed to be doing.
no, 35, but the RPM is like 1,000 or 800 or
It should be way more than that.
Really? But it
Yeah.
sounds like it's going to blow up.
It's not going to blow. No, it's not going to blow up. This fan, I have the balance report. Do I have it open still? Yeah, I have the balance report.
I mean,
right
to
here.
me, it's
This
loud.
fan is designed for AHU1. It is designed for 120,000 CFM. This is an enormous fan. It's designed for this whole building. You're only doing one floor right now, but this fan is designed for. So that fan is a very, very large fan.
No,
So
it is large, but when I hear it going anything I haven't heard it go over 1,000. But I think I've heard it go up to 900. It's making a lot of noise. It's
let's
very
see.
loud.
Okay, so this fan was
I don't know if
driven.
it's gonna
This fan
fly
was
off the
driven
roof.
at.
It won't fly.
This fan, when the balancer measured this fan, he was running at 75,000 CFM, right, which is like 60%.
I'm talking about RPM.
Hold on. He was running at 74,370 CFM, cubic feet per minute of air, on a fan that's 120,000 cubic feet per minute of air designed, right? So he's running at about 60%.
Right.
He had the supply fan running at 75%, all right? So that supply fan was running at 75% of 1,780 RPM. So 0.75 times 1,780, you get a calculator because I'm not that smart. 0.75 times 1,780. When he balanced this fan, he was running at 1,335 RPM on each blower. That was his balance position in 2016.
Right.
Okay, so in 2016, he ran this fan at 60% load, and he was running it at almost 1,400 RPM. So if we're running it at 1,000 RPM, we're running lower than what he balanced back in 2016. We're running low, right? So I want to see that number rise, and I want to see that Siemens can actually maintain a pressure set point, because just because it's rising doesn't mean anything. It has to maintain, right? So I want to be able to
Does it say
say
the RPM? Does it actually say everything like the hertz?
no. That shows you percentage. Percentage is percentage of 60 hertz, but really it's percentage of span. So because that thing has a minimum hertz of, I think it has minimum hertz of like 10 or 8 up there, it's not going to be 0 to 60, it's going to be like 5 to 60, right? So when you get to 50%, you actually are like more like 35 hertz on the VFD. But that doesn't actually matter. The issue is the static pressure and the static pressure set point. And right now, we have a static pressure set point of 1.9. We're running at 0.41, and this thing is still down at 45%, which means it's running at like 30 hertz. And it's not trying to get to the pressure set point. Or even if it is trying to get there, it's not doing a good job of it. Now, if it does do a good job of it and it gets there, and it overshoots, is it going to take just as long to go back down? This is bad programming that we're looking at here.
Yeah.
We're watching bad programming. And that's why I'm trying to tell you, if you want to have this thing work, where you don't have to think about it, then the thing you want to get rid of is Siemens. And the way to get rid of Siemens is we take over this air handler. And after we do that, you'll see how good this air handler is. And when you have enough money, you take over the third floor. And you'll see how good the third floor is. And then when you have enough money, you take over your plant systems. And then you'll see how good those are. And over the course of buying those systems, you will have complete control of your building in automatic, and you won't have to do anything. But right now, you have the same building you had 6 months ago, you just have a different way of looking at it.
Okay. I get that. I just want to make sure that whatever we're able to adjust here is the same as we were able to adjust over there.
Whatever you're able to adjust here is the same you're able to adjust over there. But whatever they were able to modify programming over there, you cannot modify programming over here at all.
Right.
So the way this thing is ramping, you cannot change. They can go over there and put in two inches just like you put in 2 inches.
When you say, okay, when they modify program, that's Siemens itself. It's not the engineers.
Yeah, the engineers can do exactly what you just did. Set it
Okay.
to 2 inches and have it not work.
Right. So then when it doesn't work, they call Siemens and say, hey,
Your thing doesn't work, and then Siemens comes out and probably puts a Band-Aid on it because they have no budget here, or they pay them a la carte to come out and do something one day at a time. Right? And it sounds to me, based on the conversations I've had with 500, is that Siemens and them are kind of breaking up, and Siemens isn't responding to a lot of their calls. They have alarms all the time, no one's taking care of it, so they're having issues with Siemens.
yeah.
Siemens has nothing to do with me, so I have no clue what the contracts are like. They might not have a contract, and if they
No,
don't
they
have a
do
contract,
have a contract.
so that has nothing to do with me though. I have no clue about that.
Right.
What I'm doing is giving you this system, and I understand what you want, and I want to give you everything that you want. But I can only give you everything that you want that you buy from us.
I get it, but I understand. Put the programming aside. Let's just say whatever was pre-programmed last year should get us to whatever 73 degrees
No,
AC.
no, you're conflating the two things. Nothing here gets you to something. What you have here is a way to write to their points.
Right.
What gets you there is the programming. So I can put 73 degrees in. I mean, I can't put it in the VAVs, that you don't have.
Right.
But I can put in a temperature set point right now. We put 55 in this morning on the discharge air. I can't get you there.
Well, that's because the 80-ton unit is
Right.
not. Is not.
So we can't do anything different than what is currently being done. We can just write it. All you're saying is, I wish it was 73 degrees. I wish with you. But I can't do anything about it until I'm doing it. When I'm doing it, then when something doesn't work, you don't say, what's the problem? You go, Josh, fix your problem. And then I say, Dinesh, why do I have a problem? I better not have a problem tomorrow, right? And then Dinesh fixes the problem or figures out, hey, it's actually a problem because their cooling tower's leaking, right? And we figure that stuff out. But right now, all I can do is exactly what I'm showing you. Give me 55. It can't. Give me 2 inches. It won't. You still have the building you had. You just have a BMS that is looking at it from your side and is now expandable on your side. So now the next step is expand.
Okay.
Okay, let's continue. Okay.
So now on this screen, I know it looks a lot different than what it did next door. Are we able to go and explain what every set point is? Or are the green
So things that
Green's
are green are
automatic.
set points that you adjust.
only the green?
Only the green.
And the yellow?
The yellow are things that are outputs that are, or inputs that are functioning, right? Are those just outputs, the yellows?
Yeah.
Yellows are outputs.
Outputs.
That's the stuff that if you wanted to override, you could, but shouldn't. And then purple is overridden, correct?
Yes.
Right, so purple is overridden. So you see your return fan, speed, and command look like they're overridden from here. Or speed and something looks like it's overridden from here. And you binoculars for this.
So the green ones are the set points, which you can set. Okay.
I'm just.
And look, he's got that window open that explains the colors.
Yeah. That's why I was coming up here on the legend. So the green ones are your set point,
Okay.
which you can set according to what the value you want. Okay. And then the yellow ones are your command override, like the ones which you can override, like the chill water valve, the fan command, the speed. Okay. Apart from that, the whites are your monitoring points or the lab data, which are
So
your feedback.
this is the numbers that's coming back from
Yeah.
upstairs, correct?
Yes.
The white.
White. Yes.
So the yellow is.
Yellow is your command override. This one.
So that's when you put things on hand.
Yep. When you put that in hand, it goes to purple because that is the Niagara color. So when you override it,
And is this okay? So it's purple. This is
Yeah.
where you're actually overriding.
yep,
Yeah.
yep,
At this in this. Okay.
yep. So right now the speed is overridden to 50. It would be like 20 or 30, but we have someone has overridden it to 50. So you can see.
I think
like
you
the
guys
fans-
did it, right?
No, not on this. we did was on for the supply fan.
Okay, so can we put everything on
Yeah, we can
automatic,
put it, yeah,
just
we
so,
can put
so
it
we can see
auto.
what the program does at least, so
Yeah.
that nothing's on hand?
Yep, I can do it.
Yeah.
Okay. And
Okay.
then if anything goes, about like
So Nash, make him do it.
Yeah.
Make him do it.
I mean, should we start on, wow, I need my glasses.
Yeah, it's okay.
Do you want to do it, Agapios?
Oh, it's okay. I can record after this. I can.
you can go to speed,
Okay. Right click?
right click, yeah, and do the auto,
Okay, and then,
and it goes to auto.
20% if
okay,
it's
can we
auto.
do it for everything and
Yeah.
see what happens? Or
Yes,
no?
sure, can do it.
And,
90%.
I'm sorry, the green,
We have
These are your set points.
we have one here.
Do a set. Set.
so
And-
the damper?
yeah, it's on. 10%
Yeah,
right now.
economizer jumper.
It's overdone.
No, but so
It's 10% now.
is this the damper for, you know how it gets the outside air?
Yes.
Yeah.
So right now 10%, like the outside air damper,
And what would be the automatic setting?
you have to do the.
You
override.
can make it automatic. Okay, you can do it.
So
25.
Should we do that or not? Oh, we need the air to go back, because right now it's being dumped on the roof.
Yeah. Right.
Can we shut the dampers so nothing gets dumped outside?
No, because
That was an issue that we had.
how it is controlled is you
So
have.
just so you know, also, just because I'm looking at the balance report as I'm trying to look at some numbers here, when the balancer was balancing,
Right.
with the spill damper open and the fans at 75 hertz, 75% that I was explaining to you before, he had no spill. So the air wasn't leaving at that balanced condition. Actually, he was bringing in 200 CFM of outside air through the spill damper when he did his balance. So there was virtually no spill. All of it was going in. The return fan was not blowing out. It was returning 100% of the return fan and bringing in outside air. But you can't directly control those dampers. You can override them, but the control of those dampers is based on programming.
Okay, but right now, so last week we had an issue where the conditioned air was being dumped out on the roof, and I had Dan next door, I had him close them so that nothing would get spilled and it would go back. It would go back into the system because it was dumping and then bringing in hot air.
Yeah. I get it. That's bad programming.
And right now you don't.
You can
have,
override it and force it.
And right now you like your exhaust and outside they are tied together.
Right.
So if this is at 50, your exhaust would be at 50. There is no separate control for the exhaust, and your return would be like in opposite. Like
Right. So if you go to 0, you have no outside air, no spill, full return.
Yeah.
You
But
mean 0 at here?
Yeah.
Yep.
If you forced that to 0, you would have the dampers, the outside air and exhaust air would close, the return damper would open. But that may not be good. You need to know about the pressures in the system before you do something drastic like 0.
Okay, but let's say we said it's 10%.
That's too low. 10% is close to 0. I would go maybe 30%. See what that looks like.
So you mean, so we don't get a lot of spillage, so that it comes around?
You have to remember that spill, outside air are related, right? Theoretically, I'm going to do this theoretically because you don't have a theoretical system. Can I borrow your paper?
Yeah,
It's a
sure.
nice page.
Okay, come look at this. Here's the idea. Okay, air is coming back from your space, right? And it comes this way. Let's say I have 1,000 CFM at this return fan and I have 1,000 CFM at this supply fan. If I open these dampers, right, there's dampers here. They're all controlled by the same output, right? If I open these dampers 20%, let's say everything is perfectly balanced, right? Let's say I open these things 20%. That means that 200 CFM is going out. It means that 800 CFM is going that way, and it means that 200 CFM is going that way because this guy's got 1,000 CFM. So whatever leaves here is theoretically what's coming in here, right? That's the way that this would balance out, right? 1,000 CFM here, 1,000 CFM here, I'm spilling 200 of this, right? That can't come from here, can't come from here. These are all suction sides. So 200 leaves here. That means 800 comes back. But in order for this to have 1,000, it needs this 800, plus it needs to entrain another 200 from the outside, and that gives this its 1,000. So you'd have, at this position, you'd have 20% outside air, 20% spill. Now, watch what happens when I make this fan look like this. Okay, now I'm going to say you are a 500 CFM fan and you are a 1,000 CFM fan. Okay, now I open this thing, the 20% that I have before. Only when I open this thing, the 20% that I have before, what happens here is 500 comes this way, right? So now I've got 500 coming this way. I've got the other 500 coming from a mixture, let's say 250 and 250. Now I'm actually pulling in from both dampers, right? So in this situation where the return fan is undersized of the supply fan, I actually can pull in from the spill, right? So everything in this damper, in this mixing box situation, everything in this mixing box situation is dependent upon the pressures that are going on in there and the volumes being delivered by these fans. So in a world where you're trying to do no positive pressurization in your building, you might want it to look like this. In a world where you want to positively pressurize your building, you wouldn't want it to look like this, but you'd want it to look more like this, where you have a little bit less return coming up. So maybe a situation that would look more like this would be ideal, right?
And we need the positive in this building.
Of course, you need positive in every building, right? So let's say you look like this. Let's say this is a 1,000 CFM fan, and this is a 850 CFM fan, right? We're going to open these dampers, and I want to have 150 spill. That means I've got, 700 coming back this way, right? And then up here I've got 300 coming in this way. If I could pull something like that off, what I'm doing now is I've got 150 CFM positively pressurized because I've slowed my return fan down a little bit. Now, when you set all this stuff up, you set it up with pressure gauges, and you measure and you make sure that you've got and then he programs in minimum position. And minimum position gives you this. Beyond minimum position is, hey, the outside air is cold, and I want cold in here. So let me get that for free. And that's when we start seeing these things open up more, these things close. Now I'll throw away 850 CFM, go 100% open on this damper, close this completely so air can't go back, and I bring in all my 1,000 from the outside air. Right. That I'm going to do when I
that's economizer.
That's economizer when I could do it for free, right? So the situation that you have right now, I couldn't tell you. We'd have to go up there and measure with pressure to find out what is happening with your dampers. But it all depends on the volume of the air and the position of the dampers. They are all interlocked, which is why when you first program, you do all this testing to make sure that you're functioning properly.
Right. But what you're saying as far as it's tricky.
Yeah.
No, you guys won't get it.
Not from here.
Oh, no.
You're gonna break it.
There we go.
Oh, yeah.
It took me a while. By the way, this is a race ball.
Oh, cool.
Yeah.
I like that.
We need the training here for this one.
No, that's cool. Yeah. But so the dampers it's a tricky thing, right? You don't just want to arbitrarily force those, because let's say you have a situation where you close this off, right? Now I'm going to say I don't want to spill anything. I don't want to bring in any outside air. I close this off. Well, if this fan is doing 2,000 CFM and this one's only doing 1,000 CFM, what happens now is I'm actually, the pressure of this fan is going to force this fan to go faster than the motor wants it to go, and now you've created a generator. And you have a problem where you're shooting electricity back into your system. So you can't just do whatever you want with these dampers. You have to have some kind of a foundational knowledge, right? And zero is likely the wrong move, right? Zero is like, I'm going to say 99.99% chance.
And 10%.
What we're trying to avoid is outside hot air come into the building.
So you do need that, though, because that's where your fresh air comes from.
Yeah, 10%, but not
Yeah.
100%.
Agree, right? But that 10% is not just based on the damper position. It's based on the damper position and the volume of the two fan setups.
So if we were to do it correctly, we would say supply fan, I don't know, what would we set it so that it could be equal, or
You have to measure.
in other words, at what set point would we
There's no
just
there's no
leave it
answer to that
automatic?
question. There's no answer to that question. Right? So the answer to that question comes from the design part, or at least in the initial setup part. Right? You'd have to come over here and take pressures, find out what your fans are delivering in order to calculate that out. And then that's why that stuff is programmed. That stuff is not user adjustable. Right? So an engineer, when he designs something, he plans it out. Now we have a balance board from 2016, so we have some things that we can do. Right? You design based on the intent, right? The engineer says, I want to have this to be 120,000 CFM. I want this to be 100,000 CFM, which means this thing always needs 20,000 CFM to come from somewhere else. So at that point, if this thing was 90%, this thing was 10%, this thing was 10%, you still wouldn't have air leaving. You would still have air going like that. If he sized these the same, then you'd have air leaving and coming in, right? So it's all about the initial design and then the initial setup and then that initial balancing. You don't have anything initial here, right? So
but there is something pre-programmed.
Right, which you would have to assume is programmed off of those design characteristics. However, the programs that Siemens put in here came way after design, so we don't know what they took into consideration. They might have just thrown in blanket programs. And I'm telling you that watching this for the last however long we're watching this and seeing this number over here, this is not a tuned system.
Well,
it's not tuned.
Yeah, I get it's not tuned, but can we get it to at least work?
We can
Whether it's inefficient or not.
It's not about inefficient, right? The only way automation works is if you tune. You have to make it work properly. So, for instance, he writes these codes, right? Then we get on a job, and he logs into the job after he wrote the code, and he sits there for a day, 2 days, changing set points and seeing how fast it gets there and if it holds or if it overshoots, and he adjusts his proportional band, he adjusts his integral band, he adjusts his derivative band. He works on all those different things, and then I go in and I go, change the set point to 2, and he changes it to 2, and then I watch this happen, and I want to see this thing come up, get to 2, maybe 2.1, settle back down, and then stay at 2. And if it doesn't do that, then I say, then I should go back in and fix it. Right? And then he goes back in and fixes it. No one did that. No one did that here. It's apparent no one did that here. Things don't work. Right? So that's what I'm telling you. Right now, you have the building you have, and I'd like to give you the building you want. And I think we can give you the building you want. I'm positive we can give you the building.
Because right now it's 1.9, it should at least be at 90%.
I mean, this thing hasn't even made it to halfway yet.
Halfway.
And we've been here for, it's got to be 20 minutes ago we did this.
And what would be but this should be 0.9? What would be your correct set point?
So, all right, so there's some different theories behind this, right? So VAV manufacturers usually design their VAV boxes to only be accurate when there is at least 3/4 of an inch of pressure before them, right? So if you went down to your lowest floor, when this pressure set point sensor, I don't know where it is, right? But let's assume that it's close to the fan, right? If it's close to the fan, 1.9 inches isn't very high at all. If it's 2/3 of the way down in the duct, 1.9 is probably too high, right? What I would do is I would set this thing to a number, and it doesn't matter what it is, call it 1 inch, set it to 1 inch. Then I'd go down to your lowest floor and I'd measure the pressure in the duct with a magnehelic. And I'd see, am I only at a 1/2 inch down here? Well, then 1 inch is not enough. And I'd bring it up a little bit. And I would do it until I get that number. Now, here's what you do if you want to really be smart about it. If you want to really be smart about it, after you have all the VAVs online, and you know the damper positions of all the VAVs, you look at them. And you say, hey, are all my VAVs mostly closed? If all my VAVs are mostly closed, then that means the VAVs are holding back my fan. Start dropping this. And you don't make this user adjustable anymore. You make this program. Now the program says, drop it down to 1.8. And look at the VAV dampers. They're still mostly closed. Drop it down to 1.7. Look at the VAV dampers. They're starting to open. Drop it down to 1.6. Look at the VAV dampers. And what you do is you look for your most open damper. And you say, which VAV damper in the building is the most open? And if the most open one is 95% closed, is almost completely closed, well, then we got too much pressure. Start dropping it. If the most open one is like 0.6, 60%, all right, we might need a little more pressure than that because we want to try to keep these things in a range where they are holding back a little bit and maintaining their set point. Now you have volume everywhere, and you've figured out the lowest number you can keep this at intellectually. That takes a lot more programming, and it takes control of the whole building. So you wouldn't have that shot right now, but if we took this over, we would have this as a fixed set point. We could come up with a number that would work, and then as you take over the rest of your floors, we would go back to this fan, and we could program that to be that intellectual design, which is actually what's in Ashray's guides. So if if you look at the ASHRAE's ventilation index and ASHRAE's energy index, it tells you about all these different procedures that you can do that will decrease your energy consumption while still satisfying your space. That's how you do that kind of stuff. That you can't do with what you have right now. You can just tell this thing to go to 1.9 and it's going to sit here at 48.4 for the last 30 minutes.
There is no pressure.
And you still have only 0.4 inches of pressure. Yep. So right now, what this thing is trying to do is ramp this to get this to equal this. And look how long it's taking to get there. So let's say it does get there. Let's say it works and it gets to 1.9. What happens if something closes and it goes to 2.3? Is it going to take 30 minutes to get that? You might blow up ductwork with this kind of a control loop. There's no response here. Right? So this is clearly untuned.
Why would you blow up the ductwork?
Well, no. Let's say this thing ramps up, gets all the way to 90%, and we're at 2 inches of pressure. Right? Then all of a sudden a fire damper closes on a main trunk. When that fire damper closes on the main trunk, the pressure in the duct is going to rise. Is the VFD going to take another 30 minutes to slow down? Bless you. Because if it's going to take another 30 minutes to slow down, well then you have other problems. You're going to be reliant upon your high pressure limits. Maybe those are not set up right? There's a lot of stuff here that you need to think about. And that's why I say the first thing I would do if I was you is I would say, Josh, give me a number to do this fan. And I would do this unit. And then once I'm done with this unit, you have 100% control of this unit. And it'll be programmed right because I will tell him how to program it. And I know how to program it, right? So we get this one working. Then once you have that, you've got your air handler. Then get your third floor. Or if you wanted to do both at the same time, it would probably be cheaper aggregate. It wouldn't be cheaper out of pocket on the upfront, but it would be cheaper aggregate than doing the two jobs at two separate times because I would only mobilize once. So I could manage both projects.
I get what you're saying, what we can do in the future, but
I don't want it to be the future. I want it to be next week. Like I want to move forward.
I just want to know how I can satisfy the tenant on the third floor.
This is how.
Like today.
No.
So when they say it's 79 degrees upstairs, what are we going to do?
When they say it's 79 degrees, you have to go upstairs and figure out how to get your chill water to be colder.
Okay, we'll do that.
Okay.
But let's say we get the second unit on, and then now it's 65 degrees up there. We're going to need to make adjustments.
And all you're going to be able to do is adjust this temperature here, this static pressure set point here, and see what the unit does.
And this will be basically the fan speed.
This will control your fan speed, and this will control the temperature that goes out on their floor, the air temperature going to their floors.
And this 55 is what right now?
This 55 is the temperature that they want the air temperature to be, leaving to go to the VAVs.
Set point.
Yes, 55 is the set point, 74 is what you actually have. It does seem to be trying, because the chill water valve is 100% open, but we already know the chill water temperature is 60 degrees, so you don't have chilled water to make the space colder. So you'd have to get your chilled water working first. That'll give you cold water, and if this thing actually maintains 55, then your floor will go to that temperature. Now, if it turns out you have a problem on the floor and they need it to be warmer, you'd have some limited functionality changing this. You can't change the way the VAVs work, but you have some limited functionality adjusting this.
Right.
At least if you took over this fan, you'd have 100% functionality of this. You'd still have your chilled water issue, and you'd still have your VAV issue, but that's what you got, right? You'd have this. Then you could take over your third floor, and then you'd have both. And you'd only be dealing with your chilled water issues and your boiler issues. Then you would take over your chiller and your boiler, and then you'd have everything.
I mean, at this point, like I'm very curious to know what's happening up on the 7th floor. So, okay, we cannot see. I mean, like right now, I want to really know what's happening with the fan. Like
I believe the fan speed's at almost 35 hertz right now.
So if we went up there,
sure,
it would say 35 hertz.
Yes. Yeah, because we did it this morning. We set it to 50 and went to 35 hertz. Right now it's at 48.6, so it'll be close to 35 hertz. It'll be like 33 hertz. We know when this thing was going down to minimum. We saw it at minimum. We saw when he ramps it, so we know that that's working.
Can I run up to the 3rd floor and actually look at the temperature and see what? Because right now we don't have eyes on this.
It doesn't matter. You can't control the 3rd floor right now. You have no cooling.
Well, but if hold on. Let's just say there's no cooling.
There is no.
Not enough. But if hot air is coming in from the outside with the economizer thing, that could be an issue.
Well, no, it shouldn't be. Right now, you have 50%.
That was the problem last week.
It may be. It may have been part of it. But you're looking at little individual things. The problem is what I'm explaining to you,
Yeah,
right?
but the problem what you're explaining is not going to be fixed today.
The problem, no, it's not. It's not going to be fixed until we make a decision to fix it.
Right.
Right. So, but that once you make the decision to fix it, it won't be that long after that it's fixed. It'll take longer if we don't make the decision. But what I'm trying to tell you about, even with this, let's say this coil here, let's say everything's operating the way it's supposed to operate. Minimally, I should be able to get 25 degrees across that coil. So if it's 80 degrees outside, I should still be able to get to 55 degrees over here.
Yeah.
Should still be able to get to 55 degrees.
We can put this chiller 2 on. We just got to put water in the cooler.
But do you understand what I'm saying? That even if you were bringing in 80 degrees from the outside, even if you're bringing 85 degrees, this unit's probably designed in New York to be somewhere around 90 degrees at your temperature. Now, that's not at 100% outside air. That would be at a mixed outside air, 40 to 50%, depending on how the building was designed, right? But I still should be able to get, if I have a mixed air plenum of 82 degrees, just like this, I should have no problem getting to 55 over here.
Okay. Can I physically go look at the dampers?
Sure.
Does this? So you're saying this is 50%, and what's this?
50, 50, 50. They're all 50.
Okay.
And you don't look at
Is
the damper
there
blades, you have to
screen
look
that
at
control the dampers? Or
you
that's
can,
it?
you can override the damper here, but it's overriding.
But why is it equal? Because the issue was.
It's the same voltage signal from the controller to all three dampers. All three dampers are controlled by one
So
output.
Dan was able to control them individually.
No, he wasn't.
Yeah.
No, he wasn't.
He was literally. I was telling him, can you close the dump? And he literally he did it in one direction. And I said, no, you just opened it, and then he went
That does
back.
not appear to be the way that it's currently programmed. It's all three of them are controlled by the same thing. So this one and this one match, and this one's inverse. So right now everything's 50. But let's say this is 20, this is 20, this is 80. So if
And
you,
50 is the program, or is 50 is what we
50 is
said?
in the program, yeah.
Okay.
That's not overridden.
Can I go run and look? Because
Sure.
I feel like hot air is coming in.
Hot air is coming in. You have 82 degrees in the mixed air plenum.
Right.
Right?
So
I have 76 degree return air temperature. So 76 degree return air temperature, 82 here, means that I'm bringing in something hot, and outside I've got 92 degrees. So it's very
right.
possible.
So what I'd like
I've got
to
a mix.
happen is this to be cycling in and to minimize this.
That's what you have. I mean, it's minimized right now. That's where it's at. It's at that minimum
Is
position.
50%? Does that mean? Is 50% mean 50% open?
No,
Or is it
50% means a
10%?
50% damper signal, right? So it's the if you look
it's
at
supposed to be set at 10% fresh air.
that's not accurate either, right?
Right.
So you want 10%, right? No buildings. Since I'm doing this for 25 years now, and I haven't seen 10% ventilation since the late 90s. Right, the late 90s was the last time you saw 10 to 15% ventilation. That is gone. No building is ever designed for 10% ventilation. Most of these things, the smallest number you ever get to is 25% now. Right, the ventilation index has to do with per person in the space and space square footage based on the occupant design. So let's say this is like a classroom. Let's say this was done as a classroom. This would be 15 CFM of ventilation per person in the room plus 0.6 CFM per square foot of the space. That's the minimum ventilation of this space, right? So no building is designed for 10% outside air anymore. That's just not a thing. Matter of fact, I have the balance report from 2016. I can tell you what the design outside air was when that engineer designed it.
Do you have any?
Yeah. Okay.
So this is your hot water, okay, and this is your pumps.
Yeah.
They are labeled.
Okay.
Okay. This
For
is your
pump.
flow sensor, supply temp.
Yeah.
This is your boiler, and the boiler's controls are given here.
Okay.
You have your status.
Yeah.
Okay, we have
disabled.
added one more thing, like where at what time it get disabled, you would get the
Ah,
timing.
yeah.
Okay.
Yeah.
Then you have your enabled
Okay.
alarm, your safeties, and your gas valve. Is it open or closed? You
Yeah,
have
for
the
gas valve.
status.
Yeah.
Yep.
Okay.
You can see the lead boiler. It is overridden to boiler 2.
Okay.
Okay. Apart from that, you have all your unit
So
commands.
the lead boilers mean the first one that will work, or
Oh, no, the lead boiler is your boiler 2 is working right now.
Ah,
Like
it is-
whenever it comes on,
Yeah.
Value 2 would come
It will
on.
start with 2.
Yeah.
Yeah.
Okay. Apart from that, you have your set points,
Okay.
temperature sensor. Okay. This is red because it is in alarm,
Yeah.
and it is on a low limit alarm.
Yeah.
We
74.
have set low limit around 100.
Yeah.
So whenever it goes below 100, you would
Yeah.
have your
Yeah,
alarm
because
coming
it's
up.
not boiling. It's
Not
74.
boiling, yeah.
Yeah.
We can have that. Like
Yeah.
we can do it when it is disabled. We can just make sure that the alarm doesn't comes up.
Yeah.
Okay, I would do that.
Yeah. Okay.
Apart from that, you have your every set point. Like green is your set point.
Ah.
You can set it.
125.
Yeah.
This one.
Right click on it.
Yeah. Set. Right click. And set.
Yeah.
And we
You can
can.
go right like this. Right click.
And set.
You can go do the set.
Okay.
Okay. So one set it would be like
Yeah.
permanent thing.
Okay. Yeah.
You can't change it. If you have to change it, you have to again go into a set and do the change.
Okay.
Okay.
Yeah.
And if you want a temporary thing, do the
Yeah.
override.
Okay.
Okay. And
Yeah.
even on the override, you would have like a permanent duration.
Okay.
1 minute, 15 minutes, 30 minutes.
Ah.
2
Yeah.
hours, 3 hours, and a custom.
And the custom. Okay.
Yeah, custom you can put it like how many days you want.
Like 24 hours, something
Yes,
as you
yes,
like.
yes.
Yeah.
You
Okay.
can have that.
Okay.
Okay.
Okay. Is this all about and this issue hot water?
Yeah. So you have an enable point.
Yeah.
You have hot water
Yeah.
dependent on your outside air.
Okay.
Okay.
Yeah.
Then you have a standby enable.
Yeah.
Then you have OAT enable set point. Like whenever it goes below 50, the
Yeah.
outside air temperature, your hot water system would come on.
Ah. Okay.
So that's that set point.
According to my set point.
Yep.
Okay.
Okay.
And here is a pump.
Yes.
Okay,
There
so
is,
this-
radiation pump. Like when do you want that radiation pump to come on?
The radian is the first
Yeah.
one.
It
Okay.
depends on this set point. Like whenever the OAT goes below this
Yeah.
46, it would come on.
Okay.
Okay. Same is with your low and high set points.
Okay.
Okay. So this is your low set point. Like the minimum set point would be a 160,
Okay.
and the maximum would be a 180.
Okay.
Okay. So it is coming all from the
Yeah.
programming, which is done at the back end.
Yeah.
Okay. Apart from that, you have something called as history.
The history.
Okay.
Okay.
So on the left hand side, you have all the points.
Okay.
Okay. And right hand side, you have a chart.
Yeah.
So if you want to see, let me see what's the written. You can just drag this,
Drag and drop.
drag and drop, and you would
Oh.
have. all
Okay.
your set points.
Yeah. The diagram.
Okay.
The chart.
And you can, from here, you can see last 24 hours, yesterday, weekdays,
Yeah.
day to day.
The last month, last year. Okay.
Yes.
Okay.
From here, you can see all of the things. And if you want to see multiple, you can drag drop multiple.
Multiple chart.
Yep.
Okay. Today. Yeah.
You would have a multiple thing.
Okay.
You would have an OAT.
Yeah.
Okay. So
Yeah.
this is how you can.
Two different colors.
Yep.
Yeah.
This is how you can check the OAT.
Yeah. Okay.
Okay.
To see the time. Yeah. Okay. For this one and this too. That.
Okay.
Yeah.
This shows if your controller is online or offline.
Ah.
That blinking goes to red. Like when you see a dot, white dot, which
Okay.
is blinking.
Yeah.
If that goes to red, that means your controller is down. It is not communicating.
Not communicated online. Yeah. I
Yeah,
cannot
it's not
control.
online.
Yeah. Not online.
Yeah, it's not communicating with the supervisor.
Yeah.
Which you have provided.
Yeah.
On the backnet.
But now it's connected. This one.
Yeah, it's connected.
Yeah. Okay.
Okay.
Yeah. I think we covered everything here.
Yes.
Yeah. Everything here. Yeah. This is the last thing. The limit.
Yeah, that are
For hot water?
Hot water.
For hot water. Yeah. Points for
That
the.
is just coming on from the
Yeah.
controller itself.
Yeah.
Okay. So basically, your red is supply, and
Yeah.
your orange is your return. Pipe.
Ah.
That's
Okay.
why we have shown it.
Okay.
Because return is kind of a little,
Different.
cooler.
Yeah. Cooler.
Yeah, that's why it's in orange.
Yeah.
This is your red hot.
Because I need it hot, it's going to the system. Yeah.
Yes.
Yeah. Okay, this is the first one, hot water system. Okay, thank you.
Go to your chilled water.
Yeah, the chilled water system. Okay.
So in chilled water, same thing.
Yeah.
Your overrides, your set points.
Yeah.
Okay. Then you have all details here.
Yeah, it stopped here.
Stop at what time?
Yeah,
Start
should-
at what time?
Yeah.
Okay. Then you have your chillers, which says it's disabled.
Ah.
At regular intervals, it will check your, at what time it goes. It is-
Hi. Hi. Okay, let's continue because he needs a room, I think, or something.
Okay.
Yeah.
Okay. Then same thing. You can see your enable status.
Yeah.
Okay. The temperature.
Chiller.
Anything related to chiller is
Chiller 1 and 2. Yeah.
chiller 1, 2.
And the heat
And
exchanger
if you
also.
want to go to your next chiller, there is.
Yeah.
This is the navigation.
Ah, yeah.
Okay.
If I need to go to the next chiller. Okay. And the same controls.
Yeah, same controls.
Okay.
Same.
Okay.
So here is your outside air reference.
Yeah.
At what? Your temperature.
Ah,
is
the
outside.
temperature is 89.6.
Yes. Right.
Yeah. And okay, what else? We have pumps.
Yeah, we have the pumps.
Okay.
So this is your cafe
And glycol pump.
and a glycol pump.
Yeah.
Okay.
Okay.
And if you see on the right hand side, we have an elevator sump.
Ah, elevator sun pump. Yeah, this is here. Yeah.
Okay.
Okay.
This is how.
Yeah, this. Yeah, no, this easy one, the simple one. After this AHU, this is the main
We
one.
go to the age.
Yeah, this is the main one.
We are looking at the ages.
Yeah,
So
we
that
are controlling
We are
the
controlling the set point.
set
Static set point pressure.
pressure.
You are
And-
controlling the discharge temperature set point.
Okay,
Okay. Then if you want a humidity control,
Humidity
then you can
controller.
control the humidity set point.
yeah, and the dew point sit.
Dew point. We
I
had
can-
a point like dew point set point. So
I can set it.
if you can set it up, the controls would go on and see the dew point.
Yeah,
Okay.
Yeah.
Same goes with your fan. Like you have two fans.
yeah,
Okay. And there is a fan enable, like a general enable thing.
yeah. Start.
And apart from that, you have like two controls,
Ah,
like two commands, two speeds, and like one general alarm.
one driller alarm is this VTX. Yeah, and alarm normal and
Yeah, alarm is normal right
Okay.
now because it is currently at start and we have a speed of 48.
yeah.
We are not sure why we are not getting the stop.
Okay.
The status feedback. Okay. Same with your chill water control.
Okay.
We have low pressure alarm.
Yeah.
Okay. We have a free stat,
Yeah.
which is if
For
the
free.
temperature goes below something, like 35.
Yeah.
Fahrenheit,
It will give alarm or something.
it will
Yeah.
give alarm. And
Yeah.
your whole age you would
Yeah.
go stop. It would be disabled.
This one MA temperature. This
Okay.
one is the
Then
set
we
point.
have your mixed air temperature set point. Your mixed air temperature. We have two sensors.
Yeah.
We have an econ damper control.
Okay.
So econ damper controls all
This three.
three
Okay.
dampers. Yes.
Okay. Okay. This.
And you have occupancy here.
Oh
If you
yeah.
want to change the occupancy, you can just change it from.
Yeah. This is occupied. Yeah. I think this is all.
Then you have your cafe HU.
This is a cafe HU. Yeah, the same.
It's running right now.
Yeah.
So if you see, you're getting the status running. Okay, it's running from 8:31 a.m.
Yeah. Starting.
How about the chiller? Is the chiller on? Chiller 3 is on. But it's not. It's
Chiller
still
3 is off right now.
Chiller 3 is off right now?
Yeah.
Why? It should be on. It's really warm in here. The whole building's warm.
I think because of this sensor.
No, it's on. But it's short. Something's going on with it. It's short cycling.
Ah.
So the chiller is disabled, and it went down at 10:56 a.m.
Can you put it on then?
I can enable it.
No. Wait. What chiller are you talking about? The 80
Chiller 3.
Chiller 3.
Is it the 80 ton?
The little one, yeah, the 80 ton.
You want me to command it?
I just saw it. It was on. I want to make sure we're on the same page. Hold on.
Okay.
Okay. Let's continue.
Then we have HV1
Ah,
Cafe.
for every yeah, for the
So
cafe.
right now, if you see the filter that is dirty, you need to change the filter.
Ah, yeah, it's coming dirty.
Yeah,
Yeah, yeah,
dirty.
yeah.
Okay.
This good.
Then you
This is
have the
coming.
freeze pump up here.
Yeah,
Okay, then you have a supply fan.
Yeah.
Set point, which is set to 60.
65.
You can discharger set
Yeah,
point.
this is the
Then
set
you
point.
have your pressure.
Yeah.
You don't have a set point, I guess, for the pressure.
Ah, okay.
Okay. Same goes with your kitchen exhaust fans.
Yeah. Yeah. I need the down. This one HV2.
Yeah, HU2.
This one. Okay.
Okay. So
Heating
you
coil.
have stages.
Okay.
heating,
Yeah.
Supply fan.
Supply fan. And the set point.
Yep. You have the set point.
Okay.
Same occupancy mode.
Occupied.
Occupancy mode, you have right click. You can do occupied, unoccupied, auto.
Yeah.
Same thing. Occupied, you can check the duration.
Yeah. Okay.
Okay.
Yeah. And the HV2 is the same.
Yeah. Then VAVs we don't have for now.
Okay.
Then we have the exhaust fans.
Yeah.
Okay.
Yeah. The
is the
stop.
exhaust fan.
Yeah. Closed and everything. Yeah. And after this.
Then we have a miscellaneous system.
Okay.
Which have all your data like systems like what's the room temperatures that we are reading.
Yeah.
We have PDO alarms.
Yeah.
We have status from chiller. We
Yeah.
have kept it as we like the old graphics. We-
Old graphic all together.
Yes, all together.
Yeah. I think it's all just for the alarm. Just
Yeah, I would
quick
put alarm.
check. Yeah.
I would put
Because this is a very important part, you
Yeah,
know.
no, yes. Okay. So this is your alarm.
Yeah.
Okay. So you have your timestamp at what time the alarm comes up. You
Okay.
have the source, like from
Yeah.
where it is coming.
Yeah.
You have the text. Like
Okay.
if you see the supply temperature is at
74.7. Yeah.
below the low limit of 120.
Yeah.
Okay. Then you have state. You have priority.
Okay.
And you can see that it has come 3 times and it is unacknowledged.
3 times
Some-
on.
yeah. No one has acknowledged it.
In
If
the-
you acknowledge, it would say 1 acknowledged and
3. Yeah. 2 on knowledge. Yeah.
same. And then we have a class. So the email alarm class is important. Email alarm class. This system would shoot an email whenever
Okay.
you have a low temperature.
Okay.
Okay.
Yeah.
Same goes with the critical.
Critical. So
Critical
important.
is for your load detectors, free stats.
Yeah.
High priority is your
Hyper. It's
temperature
very
sensor.
important.
And then you have a low priority, which is a filter.
Yeah. Like for example, cleaning the filter, it will come, but there's
Yeah,
no
filter.
alarm.
Yeah.
Yeah, but it will be low.
Filter.
Yeah, it will low priority or something.
Yeah, low priority or high priority. It depends.
Okay, so is the alarm here just for my knowledge and to fix it. After this, how it convert to green again? Like
Okay. So right now this is at 74.
Yeah.
Okay. So whenever it goes above the
It's go
low
up.
limit,
It's automatically.
yeah, automatically it would go to green.
Yeah, yeah,
Okay. Same with this. If you remove the filter,
Yeah.
you clean it, you put it back, this will.
This
to
is will be yeah.
Okay. You
got
would
it.
just have this showing up so
Yeah.
that you can get the data.
Yeah.
When it came up, when it get back to normal, like you had this filter in dirty.
Yeah.
Okay. And it came back to normal on 25th.
It's
Feb.
cleaned. Yeah, 25th. Yeah.
Okay.
Very good.
So
Yeah.
this is how you can do it. If you want to acknowledge,
Yeah.
I would acknowledge the
For the first one.
temperature.
Yeah, like-
So click on this.
Click on this. Okay. And you press acknowledge.
You can do the acknowledge.
Okay. What about this silence and if you want to stop something or
Which one? Silence?
Si-
Yeah. If right now it's like if you want to silence the alarm which is coming up on the network, it says you would have noise on it. Like, you go to this screen,
like sound or something
silence.
beeping,
Yeah,
like
beeping on the machine.
yeah.
If you want to do it,
You can silence it from
You
here.
can silence it.
Yeah.
If you want to put some notes, you can just put the notes up.
Like we fixed something, we removed something.
Yeah.
Yeah.
And see, I have told you that if we acknowledge, you can get it on acknowledge.
Yeah. Yeah. Change it.
Yeah.
Yeah. 0 and 100. Yeah. Good. Yeah.
Okay.
That's
And
all. Yeah.
The time range you can have. For now, I guess we can have a 500 or 5,000 alarms on it at one time.
Ah.
So you can go and see what was the alarms that came up 7 days back,
Yeah.
1 year back,
Yeah.
unless it doesn't goes above the limit,
Yeah.
which might be, I have not checked it, but it is 5,000. So
Yeah, it's
you would have
5,000
5,000
too
alarms
much.
list.
Yeah, too much. Yeah.
Okay.
Okay.
So this is how you do it.
Yeah.
So you good with alarms?
Uh,
Any doubt?
Yeah, it's okay. With alarms, very good. We covered everything.
Okay.
And we covered this side also we covered here. Yeah. Anything else?
Yes. So I would let you know how to do the users.
Yes, the user.
Okay.
Okay.
So you go to this part.
Okay.
You have
New.
something called new.
Okay.
Go to new.
Okay.
Then what type? How many users you want to add?
We
right
need.
now, if you want to add one, I would add yours. First.
Okay, let's add me.
Okay.
One.
Dinesh, you have a Tosi box in your car
Yeah.
for Giuseppe?
Yeah.
Can I have your keys?
Sure. Okay.
Where is it?
It's in the parking.
Is
Okay.
it the trunk?
Yeah,
Or
back
back
side.
seat?
Back side. Back side. Okay. So
Okay.
here you can go with
Name.
name. What do you want?
Okay. Let's say Agabi. AGH.
AGH
A. B for Ben.
B
No. B for Ben.
AGHB.
AGH. ABY.
B.
AY. Yeah. Okay.
Okay.
And
Then if you need a full name,
it is. It's okay. Basta. B for boy.
B
AS.
AS.
TA. Yeah.
Okay.
After this enabled, true.
Yeah, it's enabled.
Yeah.
If you want someone like if you're
expired.
doing, like
Like-
maintenance guy.
Yeah.
And you
For-
know that he's not there next year, you can put an expiration.
Yeah. Expiration
So
on.
after that, he won't be able to log in.
Yeah.
I
It's
mean,
like.
I don't want to interrupt what you guys are doing, but
Okay.
I'm having a problem. Whatever we had set last week, we had Chiller 3 to be on. Right now, it's not on. It's switched to Chiller 2. Chiller 3 is not on.
Okay.
So
He's
Chiller 3 on.
He's bringing something from car, and I think he's coming. You can
No.
ask him.
No. Last week we had a problem. It was switching from Chiller 3 to Chiller 2 every 20 minutes. We don't have Chiller 2 operational.
Okay.
We only have Chiller 3. I don't know how it got switched, but something got switched today.
Okay. We can.
But
Let's
we
stop
need
this.
Chiller.
Okay. Let's
It
continue.
also affects this room.
Yeah.
So now, can you just see if the chiller water temperature is better or not?
It just started.
Like let's see what it is, and then let's look in 10 minutes. And
Look at the temperature that's entering the heat exchanger. That seems to be the best number off your
right
chart.
here.
Right there.
And it chiller would come
74.
Yeah, that's the reacts to.
So let me just look at that.
They have reservation? No?
No, nobody emailed us.
Oh.
But we're gonna be here for yeah.
It would take time to come up because the status still is disabled. So there might be some period to chiller come up, and we don't know it.
Say that again.
I couldn't hear what you said.
So
The chiller
now
status- yeah, it
now
got-
it's enabled. Now started.
So there is like a lead time when the chiller comes up, and right now we don't have that point. Like in 15 minutes it's coming up, or 10 minutes it's coming up.
Yeah. Now, but it's working. If I check
Yeah, it's working.
the roof, it's working. And this means this temperature will go down. Right?
Yes.
It's if it stays on chiller 3 on.
Dinesh, do me a favor. Take me out of the alarm list. I'm getting like 100 alarms from this BMS ever since.
Yeah, I would do it.
72. It's going down.
It's going
It was 76.
Okay. So now that it's on, it should work. Okay. So the only thing that's overridden is this.
Yes.
Everything else is whatever was set.
Everything else is either set points that are adjustable, the green ones, or the yellows are outputs that are not overridden.
Yeah.
And so can these be overridden at some point or
They
no?
can be, but you shouldn't, because then
I don't want to do it. I
because
just-
then you're telling the program not to be in control.
Right,
Now,
okay.
if the program is doing the wrong thing, you have no choice. You're going to have to override.
Okay. So what else is overridden on the system with the fans? The fans were about
Can you show them the
1,000
list of
1,000
overridden
CF.
points? Actually, no. Make him get there. You let him use the mouse now, because I want him to get comfortable
Okay.
doing it.
So, Agapios, do you want to do this? You wanna
Yeah.
do it? Or whatever. So I would be going to.
You would be going to
Hey.
overridden funds to check what's been overridden
Okay.
throughout the building.
We can
So
see.
now we have less points.
Yes.
This
We took things off along the way. Remember, we released the fans and we
Yes.
pushed the set point up, right?
So what's this cafe? Can we see? Can I click on this and see what it is?
So you have to go to the cafe unit, and then you need to check.
You select the cafe unit. This.
Okay, right here.
Yeah.
And now what am I?
Oh, go to pumps. Sorry, it was a pump. Yeah,
Pumps.
go to pumps. Yeah.
There you go.
Is it a double click or is it a single click?
Double click.
Double click. Okay.
There you go. Hot water pump 2 is overridden. See purple on the left? Bottom left?
This one.
Yeah.
Right there, correct.
This one.
So should we put it on?
Yeah, you can put it to auto.
So
Right click on it and auto.
okay.
So it would
Now, if you go back, I think it will be removed.
yeah.
Yes.
Yeah.
Overridden funds.
Yeah.
Now you don't have 3 seconds.
It's not there.
Okay. So what's this one?
That's
Hot
your set
water set point.
point. Yeah.
175.
Set point.
Yes.
So that was probably overridden from way back when we did the boilers and we changed the set point up higher so you can get your floor warmer. Remember your floor was cold?
Yeah. So should we do?
You could enable that. You're not doing anything with it now anyway, so it doesn't matter. Your boilers are off.
Okay. So I would be going to
HWS.
hot water system.
And then there's your set point right in the middle of the screen, it's the purple one.
Okay. So what should it be?
Just enable it.
Yes, like make it auto.
So it's at 160.
Yep. That's your low limit.
And we have one here.
We raise it on the low.
Yeah, you can.
And then your lead lag is overridden also on the middle left.
So if I this is the setting here.
Yeah, you can. Down, set. And this way.
Huh? Okay, what should we set it at?
What should be a low?
What are you trying to set?
The hot water supply.
It's hot water.
Low set point.
I wouldn't set any of that. That looks to me like it's a reset schedule, so you have to look at all 4 of them at the same time before you make a decision. Sorry, I have bad eyesight, I can't see from back there.
Well, we had.
So
we had
outside air
overridden
temperature
and
enable
set
set point, hold on. Outside air temperature enable set point is 50 degrees. That means when the outside air temperature gets below 50 degrees, it'll turn on your boilers. The radiation pump outside air temperature set point is 46 degrees. That means your radiation system, your fin tube, the perimeter radiation, doesn't turn on until outside air temperature is colder than 46. Hot water supply low set point, hot water supply high set point are the outreaches of your reset. So your hot water system will maintain temperatures between 160 and 180 depending on outside air temperature. Since it's cold out, since it's hot out right now, you have the coldest set point, which is 160. I don't think you have a problem with those numbers for right now.
Okay, so we're leaving that.
Leave those, you'll be fine.
Okay.
Now the only other thing you have overridden on this page is boiler 2 is your
Boiler
lead
two.
boiler,
Yeah.
and that was because you were doing it manually because you were switching that valve that you had to control manually on the
Right.
boilers.
we just
So
want
not
it
change
on.
this one.
No,
Yeah.
we need
You
boiler
need,
two.
no, you need.
We
to
need
leave
only
that
boiler
two.
too. Yeah. Yeah.
If you leave that like that, you should be good.
Overridden points. We only have the boiler and the chiller.
And the chiller, that's it. And then you have a test alarm that
That we create.
Yeah.
For the testing.
correct.
Okay. All right. So now where are we going?
So we were.
We want to continue
I just
the
want
user.
something.
This is the last issue.
You should have him make usernames and passwords. For
Yeah,
This
yeah.
way,
This is what we are
Yep.
explaining now.
Okay, hot water. I just want to go through every single screen. So chill water system. So I would have to click on show 3 to
Yes.
see
Yeah.
what it's doing.
Yep. Like it was a big, diagram. That's why we put it into two
Yeah.
sections.
The temperature looks like it dropped a little bit. It was 74 before, right?
Yeah, but it went to 66.
Yeah. So it's coming down, but it's still way too hot for chilled water.
No, I know, but it wasn't on. That was the issue. It,
Yeah,
it,
yeah.
it cycled off for
But
some
it
reason.
is coming down, so we'll see if it gets to that 44. If it gets to 44, you'll at least get cooling in the building.
Right. Okay. So we're on chiller 3. Let me just go back to pumps. Are these in use? Glycol is not in use.
This looks like heating stuff, so all that stuff should be off
Well,
right
no,
now, because
glycol is we shut it down. So
it is shut down, but it's also, you have that outside air temperature set point that starts things. So everything here, even if everything was powered up, it should be off. If the programming is working properly, it should be off.
It's off.
so
Yeah.
glycol's off. Cafe hot water pump.
Yeah.
Okay.
This is AHU, number 1. Office
Speed is
building.
at 49 right now.
Yeah.
Huh?
49, the speed.
Yeah.
Yeah.
The
I
speed
think
of the fan.
upstairs was like at 35 hertz or something. I don't remember exactly.
So that's 50%, right, Joshua?
Hold on.
One more time.
We have this room.
What time?
Okay, come back. Yeah.
There's a lot of bad blood here.
Yeah.
Oh, I can understand. Okay.
This
So
new.
Go to new.
Okay, we'll add
Number
it.
of devices to add, like number of users to add. Right now, just
1.
add one.
We'll start with 1.
Okay. Then go OK.
Okay, let's make it like anything.
Yeah, we'll just put for now. We'll just put.
Yeah. It's just like test. Okay. So we have the
Or
name,
just put
like Agabi, ADH,
A G H
ABY.
A B Y.
Okay.
Okay, you can put a full name. You can edit it later.
Yeah, Basta, PAST. Yeah. Okay. And
So your role,
admin.
admin.
Okay.
Okay. And if you want, there is a language you can select.
Oh.
Digest scheme. It's all good. You don't have to.
We don't have.
Select the digest scheme. It's just to see how the user looks.
Okay.
Okay. Then you have
Password?
your password.
Okay.
You can set your password.
Let's do
I would put it right now as admin at
admin.
3, 4, 5 because we need a set of
Yeah.
10 letters, one small, one caps.
Yeah. And
keyboard
this
and
is.
everything.
So let's do it like random, and we'll
So
change.
You can change it later.
I'll change it. So
So it's admin 1, 2, 3, 4, 5. Same with confirm.
yeah.
Admin at the rate 1, 2, 3, 4, 5.
Okay.
Okay. Then if you have any email address, you can put any
Okay.
email address.
And cell phone. It is not responding yet. Yeah. I think the internet or something. Or the team viewer.
Okay. Then you can.
It's taking time.
Okay. You can put email address, cell phone.
Yeah.
That's all. Main basic
Yes.
is your password.
And the username and password.
And password.
Yeah. Okay.
And then you can.
Press OK. It's not responding. It takes time. So it's appear here. Okay. But it's not responding yet. We must wait until it responds or something. Yeah, maybe the team viewer. Yeah, but it takes time until it responds. Maybe the internet, because the internet is You see?
Yeah, I guess
The
can
Wi-
you just do the users.
the Wi-Fi, the Wi-Fi. You see?
Yeah, yeah.
Just give one signal.
I was connected to the Wi-Fi up here.
Uh,
The guest one.
guest one. Oh, yeah, that's very weak.
Which cast?
No, we have this one.
We have the T-Mobile and there's
We
a
have
password.
T-Mobile.
Do
This
we have a
one.
password?
Yeah, I have the password. Okay,
Connect.
Let me go to.
but
Who's Galaxy?
That's mine.
Oh, your personal.
okay.
Okay. So if you see, you have your user.
It's already here. Okay,
So just log out.
and we'll log in again.
Change the user.
We can add it Agabi.
And it's case sensitive.
Yeah.
The username and the password is case sensitive.
Okay, so capital A,
Okay. So it's
G.
AGHABI.
Yeah,
Then
Agapi.
do the login.
Uh,
Go up here. It should be a admin
admin.
at the rate 1 2 3 4 5.
Okay, login.
Login
Okay.
now.
Who was
There's-
1, 2, 3, 4, 5?
Huh?
Who was 1, 2, 3, 4, 5? The admin?
For me, this is just like start password, and you can change in the future. I can change it, but it's just start. So what happened here? I don't know what's
So there's
happening.
one setting that I need to. open.
You need to do.
Yeah,
You need to open. Okay. You
Once
must.
you are done, you can duplicate your user.
Ah.
To make more users. That would make your.
Yeah.
Nick, is everything okay?
Like add new
Yeah,
user.
it's fine. I just don't know who he is, and nobody told us that they were using the room. So I looked at my emails. So I said, if you want to use
Yeah,
that
you
12
need
or
to have
an hour,
one of
that's
the
fine.
files. That's it.
Yeah.
I don't want to cause any trouble.
No, no. I'm just checking my emails to make sure I didn't miss.
This is programming issue, not related to me, right?
Supposed to
No, no,
email
it's
us.
not.
This for you. Yeah. It's not reading.
Right, because this is like
Yeah.
almost like a contractual easement between on this floor, right?
Well,
Yeah.
But they need to give us notice.
Good.
Right.
Very good.
Hey,
Yeah.
turn on the AC.
Yeah. Okay. Now I think it is.
We're using this room.
We covered
Yeah,
everything.
We're using it.
Or there is.
Yes, we have
Because it's
covered
your
everything.
room, but
So
they
if
Yeah.
you
they
want
want
to
by
We
request
have the
the
right to
link,
use it too.
Yeah.
That's what I'm saying, parents want to-
What-
it's your room.
The last issue, that he's saying, like someone like supervisor, someone like under of him,
Gotcha.
because he's saying like
They're
Nick,
supposed to let us know.
Nick, he will be
Reciprocal easement.
like the supervisor.
Yeah.
I'll be under him. How we can do this here, or it's not? Don't care.
No.
Not
You can
on-
do it, but you need to tell us like
Ah.
what's the category. that
Yeah, like category.
you
Okay.
want.
Okay.
Like someone is the admin, someone is the manager.
Yeah.
These guys. the
This you are
engineers.
making in the
Yeah.
program.
So I'm just making a general for now.
Okay.
But if you tell us, like you can just call Joshua,
Okay.
and I can do that. At
Yeah.
your service. So
Okay.
right now you can just duplicate your name and change it, or duplicate anything.
And
or
the
you
change.
can do the new one.
Yeah, and do new one. Okay. Yeah.
So
I think we covered everything now, or
no, we are good right now.
we are very good now. Okay. Thank you. Thank you very much.